Welcome to our detailed tutorial on NumPy. In this tutorial, we'll cover the basics of working with NumPy arrays, from creating them using lists, tuples, and sets to accessing and modifying their elements. We'll also look at key operations such as addition, multiplication, Boolean indexing, and working with multidimensional arrays. Plus, you'll learn how to use mathematical functions, generate random numbers, and more using the NumPy library. We have compiled one of our best live sessions as a complete NumPy guide just for you. By the end, you will be ready to use NumPy for data manipulation and data analysis. So what are we waiting for? Let's get started. Let me explain the structure of the session. So if you look at the notebook, what you will see is that there are many examples. Okay, so you will see titles, you will see various sections, NumPy arrays, whatever, and you will see examples. Okay, so there are many examples, and then you will see there are some quizzes. Now some of those quizzes are just quiz, some of them are marked as homework. Okay, so ideally the structure that I have prepared for this session, including I think the next session on pandas also on Wednesday will be similar. So what we'll do, this is we'll call this a workbook. Okay, because a lot of these topics are, I would say, in the beginning it's more practice and programming and tool related, and slowly it becomes more conceptual. So initially we need to spend more time experimenting and getting familiar with the tool. So that's the idea here. So the way that I'll go ahead with this session today is I will explain the concepts while demonstrating those concepts practically using these various examples. So don't worry about all these different commands. Okay, I'll explain all the different commands. These are all very simple commands. It just looks like there are so many commands. So don't worry. I have here almost like 11 commands or something, but you don't need to worry about that. Okay, these are all simple commands that you will learn, and same commands we'll be using again and again, right? So the whole idea of programming is to become familiar with the tool. Okay, so I'll go through these examples, I'll explain what's happening, I'll show you the results, right? And then when sufficient time has been given to a certain concept, we've gone through example 1, 2, 3, 4, 5, whatever, there will be 1 or 2 quizzes. Okay, now the expectation from the audience is that you try to solve the quiz. Okay, like in this session, right? So we'll do a few examples, we'll discuss the concepts, we'll see the results, and then you will try to attempt the quiz. Okay, and then there are some additional interesting questions which I felt is good for practice. Those quizzes I have marked as homework. Now if we have some time in the session, then we can consider discussing some of the homework questions. Of course, I'll give 1 or 2 hints as I go through the workbook, but we will not solve them right now. If there is time, then we can think about it. Okay, then I think we should start. Let's begin the session. So welcome to the session on NumPy, everyone. This is where we start transitioning from programming to data science. Okay, this is where data science starts. And right off the bat, I have to tell you, and I have to make it very clear, that NumPy stands for Numerical Python. It is the most popular and most stable and most reliable mathematical computing package. Okay, in other words, its focus is mathematical elements, and that is something that we will need going ahead. When we work with anything, any kind of data that we work with on the back end, it's going to be NumPy powering a lot of the operations. Okay, so we'll explore NumPy in detail today. There are many aspects of NumPy which you will use and encounter visibly, right? Visibly means what? You will be using commands like np.mean, np.median, np.std, standard deviation. All these things visibly you will use later in the program or later in your data science journey. Visibly you will use, and large amount of NumPy you will be using invisibly. Okay, because packages like pandas, matplotlib, and all the other data science packages at the lowest level, they need NumPy. Okay, they need NumPy. They work. NumPy works on the backend. So it's important for us, as I said, we'll be visibly using NumPy and invisibly also we'll be using NumPy, which is why the session today is designed so that we get a lot of familiarity with this package called NumPy. Okay, and it's very important for analysis and data manipulation, and its focus is that it's trying to bring mathematical concepts into a programming level. Okay, we will see how that is. So first I'm going to import the package. Now typically people give the short form np. Okay, when you import NumPy, people usually just give the short form np, and you can just import NumPy like this, no problem. But everywhere you have to say numpy.array, numpy.sum, numpy.mean. So the more conventional thing is to import NumPy and rename it to np. Okay, so let me run this, and all of you can run the cells that I am running, and follow me, right? As I walk through the workbook, follow me. So I've imported NumPy, and as you can see, it has run. All right. Okay, so directly now we are going to start with one of the most important objects in NumPy, which is called NumPy array. Okay, so arrays are the primary way of storing data when you use the NumPy library. The class is called nd array. Okay, on the back end it's called nd array, which stands for n-dimensional array. We will see why it is called n-dimensional array, but the command is pretty simple. So let's start with creating empty arrays. Let's see if we can create an empty array, because we all know how to create empty list, correct? So if I just say list equal to something, right, and then I print list, oh no, I can't call it list a equal to this, and then I'll print list a. So list a, as you can see, it's an empty list. So we all know how to create empty list. How do you create empty array? So the command is np.array. Now if I just take np.array and call the class, right, so it is a method. Okay, it's a method, which means you need to use parentheses. Okay, not like this, you can't use square bracket. It's not an object yet, you need to call the object. So once you call the class array using the method by the name of array, then this thing becomes an object. Now let's try running what happens. So if you see here, this method is missing a required argument called object. So the NumPy array needs a starting object. Now suppose I use object equal to none. Okay, none in Python is some kind of placeholder. It's actually null value. Okay, it doesn't have any size. So suppose I say object equal to none. So if I just say, for example, len none. Okay, len none. So it says object of none type has no length because it's null value. In Python, this capital NONE is a null value. There is no size. It just means nothing. Okay, but I can put that nothing in an object. Basically, if I specify my object as none and then call the array method, now I can print the array. It says that it's an array with the data type object. Okay, and if I just use the type command of Python on this object, it says that it's a NumPy nd array. Okay, now of course you can just print the array using the variable name itself, but you can also use the print command. We know this, right? Now if you print this, it says none. In other words, it is a non-sizable array. Okay, and I want to get this blank array out of the way, then we will go into proper arrays. So if you see length of np array right now, it's an unsized object because we use the none data type. Okay, now you can take a blank list, right? You can obviously take a blank list and put it inside the array method. So the object here, basically the parameter name is what? Object. Okay, so np.array object equal to blank list. That's what it's doing here. Even if you don't specify the parameter, by default, if you put one parameter, it's going to be object. So let's say what happens with the empty list. Now if you see, this array is different from this array. Okay, so here it says array none and it does not have a length because the array itself is unsized because you used NONE. This is the only exception case, by the way. Every other case is going to have a length. This is the only exception case. Now in this case, what do you think length is going to be? Let me print the length one first. Okay, length has to be 0. So it is a sizable array now. Okay, if you use a list input, it is now a sizable array. Okay, and of course you can check the type of this object. It is called numpy.nd array, and you can print it just to get what is inside the array. So if you directly just output the variable, it will come like this: array bracket the value of the array and then the data type which is used. By default, it is using float 64. This should tell you that there is a parameter called data type, by the way. Okay, obviously this method must have a parameter called data type. We will see that later. So this is, the exceptional cases that I wanted to discuss before moving into the more typical cases. So please feel free to learn more about these blank arrays, unsized arrays, and things like that. It's not really the most important thing, but I think it is important to know what the exception is. Then when we talk about lists like 1 4 5 6 2 3 4 5 whatever, then we know, okay, all this is sized arrays with different sizes, and then there are some exceptions. So whenever you meet an exception, you should know what is happening. Okay. So you can also check the empty method from NumPy, and how to create more blank arrays. You can take your time later to do this. So with that introduction, let's actually start with proper arrays. So typically, you can create arrays from lists. It's the easiest way. Okay, so suppose I have some list here and it has 4 numbers, 1 4 5 6. If I just declare this sum list variable and print it, it says bracket 1 4 5 6 bracket. Okay, this is a list. And if you check the type, it says list. Okay, all I need to do is I need to take this object and pass it in this object parameter, right? And then use the np.array method. It's going to convert this object into an array. So now if you just output np array, this variable, the list is inside this object called array. So the value is 1456, but the data type has changed. So you can check the data type using type again. It will say numpy.nd array. Okay. In fact, the array itself has an attribute called dtype. And by now we should be familiar with this dot method, dot syntax. So if you have an object of a class and then you just do dot and tab, you will get all the various methods and attributes that you can apply to that. We will be seeing some of these methods and attributes today, not all. It's not possible to do all. We'll see most of the important ones. Okay. So here dtype is actually one of those attributes of the object. So now if you do np.arr dtype, right, it will give you the data type of the value inside. Now if you see I put 1 4 5 6, obviously these are integers. So these are integers. If you just type 1 4 5 and 6 like this inside a list, Python recognizes these as integers. Okay, so it's stored as integers, and when you convert it to array, nothing changed. The data type that was before, and if you see here it's green color, right, so it's an integer. The same data type has gone to the array also. So 1 4 5 and 6 inside the np array are also int 32 integers. Now are numbers the only thing that you can do with arrays? No. Okay, just like lists, you can have list of strings also. So here I have a list, apple, orange, banana, watermelon, jackfruit, all are strings. It's a list. Okay, and I'm passing it into the np.array method and then storing it in the variable. So now if you see, the list is here, the array is here, this is all fine. But here you see there's this thing, dtype is equal to this, character here. So these are actually memory levels, right? So what Python is doing is assigning memory sizes depending on the kind of data that you're passing into the array. Okay, so for 1 4 5 6, int 32 was enough to store the information. Okay, these are larger strings, so now it has changed the data type to something else. It is a string, but even in strings there are different memory levels. Okay, so then you can again check, it is still a numpy nd array. All right, and if you check the dtype attribute from the array, you will get this. Okay, this is a kind of string attribute, data type. Now what you can also do, as I told you, is that dtype is a parameter in this method. So basically this np.array is a method and a class, right? The class is called ndArray, this one, numpy.ndArray. The way to create it is this method called numpy.array. Now in that, suppose I have object 1, 2, 3, and suppose I pass my data type parameter as int. Okay. Now I'll get, see, 1, 2, 3. This is obvious. Even if I don't pass this parameter, by default, it's going to take 1, 2, and 3 as integers because Python recognizes these as integers. The same thing if I say dtype equal to float instead of int, right? Same object, and I create a new array. Now you see it stores it as 1 point, 2 point, 3 point. So I have forced these things to be float numbers. That is why you have this decimal here. In this previous case, you did not have the decimal because it is int. Okay. So what are we learning here? We are learning that NumPy array is essentially a collection of values, just like lists, and it has data type for each of these values. Okay. We'll see a few more examples. Now, if you see this, what am I passing here? -1, 5.5, 2, 3.5. This is my list. I'm not specifying the data type, right? What will happen? So here, see, 2 is an integer, -1 is an integer, 5.5 and 3.5 are floating numbers. What's going to happen? These integers will be forced to convert to float because you need to maintain the same data type inside an array. So that is one of the restrictions or conditions of NumPy arrays. Okay. So in my list, it's not a condition, right? So if I just say, if I just copy this list and put it here and print it, I just printed this list, right? Look at this. This is still integer. This is floating. This is integer. This is floating. No problem in list. In NumPy arrays, what happens is that all the data inside the array will be of the same data type. So if you see in this case, the integer got converted to floats. The reason for this, because these are mathematical constructs, the expectation is that when you use this for programming later, if you maintain a consistent data type, then you can use consistent transformations and functions on the data. Later, when you do some programming, it shouldn't happen that a certain function you are applying works only for float, does not work for integer, and that causes a lot of problem. All this is very common when you work with especially data science, machine learning, these kinds of things. This is very common. You get all sorts of errors if you have not accounted for various data types. But accounting for each and every data type for each and every function is not easy. It's quite complicated. The easier way is to convert everything to one data type, which is what NumPy is doing. Okay, so in this case, if you see, it's all converted to floats. What will happen if you have a string and a number, integer, and another string and a float? What will happen in this case? Now, see, this is a list, okay, but I am now creating an array from the list. What will happen? If you notice, this integer got converted to string. Can you see these two quotation marks? So now the array has forced this integer to be string, and this 4.5 float number, that also has been converted to string. And the string memory usage is this data type here. And if you saw previously, it was U10, now it's U32. As I said, these are different memory sizes to store the data type, right? But these are strings. In the end, these are now strings. So note that the numbers have now been converted to strings. So the restriction in arrays is very clear, right? You cannot have various data types in the same array. The reason for that is that we want consistency so that whenever we use arrays in the backend, and if you remember in the beginning of the session, I said that visibly we will use NumPy methods, and invisibly it is used many places. Like all the data science packages in Python, all the machine learning packages in Python, they use NumPy invisibly on the backend. For them to work, we need this consistency in the data type. Okay, so this is just a short introduction into data types of arrays. I hope there is some clarity here, right? You can, of course, query your GPT or something else, to learn more about these things. You can go deeper into this. Okay, all of these, by the way, I have given, a lot of statements in the workbook where I have written, hey, try querying a language AI model. That's something you can do in your free time. Okay, so first let's get all the basics nice and strong. Then in your free time, you can investigate more. Okay, if your interest so decides. Now, creating from list is very obvious, right? Creating arrays from list is very obvious. What happens when you create from tuples? Now, see, for some of these things you will not spend so much time. Typically, creating from tuple is not something that we do. There may be some cases, where it helps, but it's the same thing, right? A tuple is nothing but an ordered collection of numbers, just like a list. So for example, I have this tuple here, -5 1 -4 7 2. Okay, and I just print this, and as you can see, it says class tuple. All I need to do is I need to pass this tuple to np.array. That's all, and print and see what happens. So if you see here, you have these what do you call, the curved brackets. That means it's a tuple. Now you have your list brackets, so which by the way means that it's a list of numbers in the form of an array. Okay, think of it that way. So right now it's, and if you're confused or doubtful about what the class is, sorry, data type is, just do type of object, right? This command is very, very useful. I've used it so many times. This type of whatever. If you have a variable called x or any variable called var, at any time if you're doing any debugging, check the data type or check the object type. Okay. So here it says numpy.ndarray. We won't go more into tuples. It's something that's typically not frequently done. Okay, mostly people will just convert from lists. From sets, what about creating arrays from sets? Now we know sets, right? And we also know that sets are not ordered, which means you cannot. Okay, that's something we should talk about, right? So suppose I have list equal to 0 1 2. Okay, so it's a list of not 0 1 2. Let's say ABC, list A B C. Okay, I can't call it list A. Okay, so suppose I want to pull out the letter B. So I'm going to say list 1, correct? So that is going to, sorry, list A. So that's going to give me B. Same way, if I do, tuple A equal to, and I'll just create a tuple with ABC. I'll just copy this from here. Okay, tuple ABC, and then I say I want the letter B. What do? I just need to do this, right? Again, I get the letter B. In sets, it's not like that. No? Sets are not indexed. So if I say set A equal to, and I just put this thing inside the set. Okay. So if I just put it like this, and then I say set A of 1. If you see, it says set object is not subscriptable because it's not indexed. Okay, it's not ordered. So does it make sense to create NumPy arrays from sets? Definitely not. Arrays are strictly ordered list-like objects. Okay. So just to prove the point, here is some set. Okay. And if I just print it, you can see already here I have the value 1.3 minus 5.6, 2.8. But when you print it, the value gets changed. Sets don't have any inherent ordering. So if you try to convert, into NP array, if you see here, it still preserves the set brackets, the parentheses. It did not become the square brackets. So now obviously the set also you cannot index. What about the NumPy array? You may think, okay, right now it's an array, so maybe I can index it. No, if you try to index and pull out the one by one elements, you cannot do that, because see, the array is 0-dimensional, which means this is not having any array element. Okay, so typically we don't convert sets to arrays. It causes all these issues, and primarily the reason is that sets are unordered, arrays are ordered. So converting set data to array data is almost makes no sense, right? I have not come across a single case where we do that. Now I have shown you creation of arrays of different data types. So if you see here, string, integer, float, and what we learned was that it selects the suitable data type and converts everything to the same data type. Okay, so in this case it got converted to string. In this previous case, everything got converted to float, right? That's what it does. What about if I use different data structures? Is that possible? So for example, I have this thing called mixed list. If you see, the first element in this list is actually a list. So this list, first element is list, second element is string, third element is float, fourth element is integer, and so on. Okay, so this list can exist without any problem, right? This list definitely exists, no problem. So if you just print it, you can see the list, no issues. It's a list, and we've studied list before. It can hold a lot of objects, fine. You can index the list. The first element is another list, by the way, here 2 3 1. If you check the type of the first element, as I said, it's another list. Second element, it's the string New York here, right? And the type of this one, it is string. So each original data type is preserved, and even the original data structure is preserved. So list is a very generic kind of data structure in Python. Okay. Now what happens if you convert to array? That's exactly what we are trying to learn. If you convert to array, you run into an error, right? It says setting an array with element with a sequence requires that array is inhomogeneous shape after one dimension. So there is something called shape, and we will get to that a little later in this session. But the problem is that it's not able to find a proper data type for this object. This is a list. If I remove this, it will be okay. It will select something like what is that, U32, something like that. It will convert everything to string. Fine. But what about this? So it's not able to find any object data type for that. So the most generic data type that I have come across in Python programming for data science is the object data type. So what if I set data type to object? What's going to happen, right? And obviously my data is the mixed list, this one. So let's try running this while setting the data type to object. It runs, okay, it runs and it preserves this. Okay. Now, is this useful? That is something that you need to ask, right? So now if I say NP array and I pull out this, I get the list, no problem. I pull the second element from NP array, I get the string. I pull the third element, I get the float, whatever. But what has happened in this case? In this case, you did nothing but created a list. How is this any different from list? All right. Yeah, Pratim, it's somewhat following a hierarchy. Yes, there is a hierarchy of data types, by the way. Correct. So it's like object, string, float, int. That's the very, I think, simplest hierarchy I can tell you. Object, string, float, int. Right? For all practical purposes, that's the hierarchy. All right. Let's all try to solve the quiz. Okay. And then we'll move to the next session. Next section, sorry. I hope we all remember functions. Define a function that takes in a positive integer n and returns an array of the first n even numbers. Assume 0 as the first even number. So do you need hints for this? One hint I will give, maybe list comprehension, if you remember. Do we all remember list comprehension? Try that. Okay. So in terms of the define function part, I'll just give it to you. So define return even or something. And you need to return what? You need to return the even nums. Okay. And it needs to take in a positive integer n. So n equal to positive means what? We'll start with one. Default value I'm putting 1, by the way. So I can also have safety conditions. If n is less than 0. Okay. So let me redefine the function. Okay. So I'm going to say def return events n and return even nums. This is what I want. Okay. So now I'm going to say even nums equal to list 2 star I for I in range n. And I'll just convert it. In fact, you can just convert into array in one statement, np dot array. So obviously you can store the list first, and then you can do this even nums equal to even nums equal to np dot array even nums. You can do this in 2 steps, or you can do it in 1 step also, right? So whatever even nums is, which is nothing but this list with a comprehension inside, that you can directly put here, and you don't need this one extra statement. Interestingly enough, you don't even need a variable here. You can directly take this and put it in return, and you don't even need 2 lines here. You can put this whole thing in 1 line. So now if I say return events and 3, answer should be 0 to 4. So when you are starting out with programming, I would suggest and recommend that you use temporary variables, right? You go step by step. But once you get more familiar with all of these things, how to chain commands and all, then you will get, this will become easier for you. Okay. So what I've done is I've chained a lot of commands together. All right. Okay, so as I was saying, ChatGPT will sometimes give you bigger answers. You need to try to talk to it and say, look, can you do it using a simpler method? Can you do it using list comprehension? Talk freely to GPT. Say that, look, your method is complex. Can you simplify it? Right? Try that and see whether it's able to give you a simpler answer. When you do data analysis and ML, you don't want complicated code. Okay. Typically, you want simple code, because the concept itself might get more complicated. So typically it's better to have simple code which you can easily pull out, understand, and debug. All right, great. So yeah, what we'll do is we'll continue. Now, as you can see here, there are some homework questions. I won't spend too much time on this because we need to cover some of the other concepts. I'll just give some hints. So again, this is a define function type of question. It says return an array of n random real numbers between a and b. So one hint is that I think you should go and check the random library. This is a library of Python. Okay, so Python itself has a library called random. So you just import random, and then you please explore the methods that are available. One of those methods will generate random number between 0 and 1. So you can try to use that 0 and 1 generator and transform it to A and B. Okay. So don't do this right now, guys. Okay. Do it in your free time. And of course, you can query your GPT and try to see if you're getting what is required. Okay. There's another homework quiz here. What does it say? It says define a function that takes in a list, okay, and returns two arrays, one with all the numeric values and one with all the string values in the same order as the list. So obviously this input list is a mixed list which has string and number, right? So what your function should do, it should take the list as the input and it has to return two arrays. One array is going to have all the number values and one array is going to have the string values. Okay, assume that the input list only contains some combination of numerical and string values. This is also a fairly straightforward question. You should be able to return two arrays, and again you can take help from GPT if required. But if your code is becoming really big for something simple like this, then talk to GPT and say, look, you have I don't need this step, or say please simplify it further, whatever. Okay. So that's the idea, guys. We will not what happened, what's giving error, import numbers np. Let me check this. Pratim, let me check your answer. What you're saying is if import numbers np, that's fine. Even list is blank, j equal to 0, f even check. This is unnecessarily complicated, I feel. For I in range 0 n, yeah, that's the thing, right? This is fine. It may give error. I'm not going to debug the error right now, Pratim, but it's fine. The logic is okay, but it's inefficient. See, now in this case, you're generating every number and then checking, are you odd, are you even, are you odd, are you even? Why? Because the first n even numbers are nothing but 2 times the first integers. So all you need to do is you need to use this range function, right? Very basic Python method. Range 3. So what does this range do? For example, if you just say range 3, it gives 0 to 3. Now if you say for I in range 3, print I. What are these I over the ranges? As you can see, it is 0, 1, 2. What is range 5? 0, 1, 2, 3, 4. So it's printing for you the first n integers, non-negative integers, starting with 0. What you need to do, you just need to multiply this by 2. Then you will get all the even numbers. 0 into 2 is 0, 1 into 2 is 2, 2 into 2 is 4. So 0, 2, 4, 6. So you don't need to use this if-else condition to solve this problem. You can, but you don't need to. Okay. I won't debug the error now in the interest of time. I would suggest that, you take your time and do that. Yeah. Great, Pratim. Thanks. All right. So, nice, what do you say, warm up to NumPy arrays. Okay. And what we have learned till now is that essentially we are using list to create arrays. Now, what you need to understand, till now we have seen one-dimensional arrays. Okay. The biggest feature of NumPy array is that you can store multi-dimensional data. Okay, and that's what we're going to understand now. This is the biggest, most important power of NumPy arrays. So we'll start with an example. So if you see here, the object I'm passing is list within a list. So you have the outer list here, and within that list you have two lists, 1, 2, 3, and 4, 5, 6. Okay, so if I just directly just print the list, what you will get is nothing. It's just a list with two lists. So if I say a equal to this list and then say a0, you will get the first list. If I say a1, you will get the second list. Nothing special. Okay, if you convert it to array, what you will see is that it is now stored hierarchically. So if you see these two things, if you printed as list, it will not print this way, right? Just print it here and see what happens. It prints as a linear. But if you print it as an array, if you convert to array and print, now it is starting to show rows and columns. So I hope we can all appreciate where we are going with this. Data science is essentially the study of data, analysis of data. Most of your data is going to be rows and columns. In fact, we spent almost 15 minutes in the beginning of the session talking about that image, sun image. Images are nothing but more than 2 dimensions. It's 3 dimensions. And we'll see that soon. Okay. First, we'll look at 2D arrays. So this is row number 1, guys. Okay. So whatever my first list is here, that's row number 1. 1, 2, 3. And this is row number 2, 4, 5, 6. Now, when you put these two rows together properly, you will start getting columns. So if you see column number 1, 1 and 4, column number 2, 2 and 5, column number 3, 3 and 6. By the way, I say number 1, 2, 3. When you index, it is 0, 1, 2. I hope we understand that. Python indexing starts with 0. Okay. So this is a 2-dimensional array. It has 2 dimensions, 2 axes. Similarly, if you do list within list within list, and this is, it looks complicated. I would say ask GPT to break this down for you. But what's happening is it's creating dimension by dimension. Okay. So it's creating ijk for k in range 3. So it's generating 3 values for k. Then it's generating 3 values for j. Gen is generating 3 values for I. So you're going to get all the combinations. Okay, and then if you just print it as list, okay, just print it as list and see what happens. 0, 0, 0, 0, 0, 1, 0, 0, 2, right? So there is no structure here. Okay, it's all actually a linear object, right? And you have all combinations 0, 0, 0, 0, 0, 1. That's what it's doing. So totally, how many combination you'll get? 3 into 3 into 3, 27 basically, right? You will get 27 objects in this list. Now, if I convert this to array and print, what happens? Notice it prints in a very different way. Okay, what you're seeing here, it's showing you cross section. It's showing you cross section. So this is the row and column, right? And then you have row and column again, and then you have row and column again, and then you have row and column again. So you have like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. You have like 9 rows and columns. There are 3 dimensions in this object. Now this will become clearer when we do the image thing. So have some patience till we go to the image, okay, which is obviously the next example, right? But what you need to understand is that these are lists within lists, okay, which are being converted to arrays. So at this stage, I'm going to use a package to read the image and show the image. Now this package is something that we will do in our later session on data visualization. So don't worry about it right now. Okay, just run it. We'll discuss matplotlib in matplotlib session. But if you import this matplotlib.pyplot, pyplot is the plotting library or plotting package used with Python. Okay, typically. And the short form given is PLT. If you just Google anywhere, you will find PLT, PLT, PLT. Same. Import NumPy as NP. NP is the short form convention given to NumPy. Same way for pyplot, matplotlib pyplot. PLT is what we use. So I'm importing matplotlib as PLT, and then I'm using this method called imRead, which is self-explanatory. Read image. That's all it says. Okay. Now I'm storing that in a variable called img. Okay. And then I'm going to use show image. So I read the image file, stored it in a variable, okay, using plt.imread. Then I'm using plt.imshow to show the image. That's all. So if you run this cell, you will get this very bad looking image. The reason it's bad is because the dimension is very, very less. The resolution is very less. I believe it is 32 pixels, 32 pixels. I mean, most of us should be familiar with images, right? So if it was a high resolution image, then it would have 1000 something pixels. You will get very nice, image, right? Later, if you want, you replace this one image with some other image and, explore more on your own, right? I'm using this very bad resolution image because I want to track the values. Okay. And if I want to track the values, then if I have 1000 values, it's not easy to have a discussion, right, in a live session. So that's why I'm taking this very, very bad resolution small image. Okay. Cool. Now, as I said, this is a very low resolution image. Visualizations we will cover later. Don't worry about Matplotlib right now. Okay. If you're interested, if you have free time, GPT is always your friend. Okay. Now, what I'm really trying to show here is not this exquisitely bad image of the sun, but believe it or not, this white patch in the middle is supposed to be the sun. This is some sand or something, and this is the sky. Okay. But that's not the point. What I want to show is this variable here. Okay, you read the image, you loaded the image into some variable img. Let's print this variable and see what it is. Surprise, right? Everybody surprised? It's an array. It's a NumPy array, right? So when I said earlier that invisibly arrays are used everywhere, matplotlib.pyplot based on arrays, pandas based on arrays, right? Everything in data science is mostly based on how NumPy operates. So this variable where you stored your image is essentially an n-dimensional array with 3 dimensions. If you see here, there are 3 brackets. Okay, so these are your values. By the way, pixel values go from 0 to 255. Don't worry too much about that. Just understand that 0 means black and 255 means white. In other words, 0 means nothing and 255 means everything, brightness. Okay. Why is it 3-dimensional? Because it has 3 channels, RGB, red, green, blue. Okay. We'll see one small example on that later. Anyway, so what I tried to show you here is that these images, all images are actually NumPy arrays. Okay, in the backend they are arrays. Now, one interesting thing about this image is that if you just check the flags attribute, which is not very important right now. Okay, this flags attribute is not something I expect everybody to understand or know. The only reason I am putting the flags attribute in this session to show you, the only reason is because unfortunately my image is not writable. It's read only. So later, if you see here, the flag writable says false. So later, we'll be doing some manipulation of the values inside this array. I can't do that to this array, unfortunately. Okay, this is a property of the file. So if you choose another file, maybe you can manipulate it. Okay, but anyway, there are ways to handle that. So I'm just putting this here to show that my file, my sun image file, is not writable. And if you print in your system right now, you should also get not writable. Okay. Anyway, so we can definitely copy it into new array and manipulate. It's nothing hard. Okay. So what we have seen till now, let's summarize. 1-dimensional arrays using lists is very simple and easy. 2-dimensional arrays are essentially matrices, right? Back in school, we used to study something called matrices. That's exactly what 2-dimensional arrays are. And when you convert this list within list object with 2 levels into an array, it automatically becomes rows and columns. That is the structure of the array. And we will see the structure using little bit more methods very soon now. And for 3-dimensional array, same concept. Okay, list within list within list, 3 levels, right? Therefore 3 dimensions. And as an example, I've shown you just reading an image, and if you just check the variable of the image, it is in fact a NumPy array, and then you will see values from 0 to 255 basically. Okay, that's just the pixel value. But the main point is that these are 3-dimensional arrays. Okay, great. Let's see the questions. Akash Astana, how? What's the question? So just given color. Don't worry about that right now. Okay, I'll explain when the example comes. I'll explain. You will get more understanding as you go through. Don't worry right now, because this session is more on the array part. Image part we'll discuss in other sessions. Don't worry. But long story short, if everyone wants to know, the within a minute what's happening, image array, what's happening, each image has 3 channels: RGB, red, green, blue. Okay. So, and all these channels are having screens. Very simple. It's like my camera screen, whatever laptop screen, X and Y, right? You have row and column. That is an image, correct? The same screen, think of in red color, green color, blue color. By varying the values in these 3 different screens and putting together, you get color, basically. Okay. So if all 3 screens are 0, 0, 0, you'll get black. If all 3 screens are 255, 255, 255, you'll get white. Why 255? Because 0 to 255 is 256 integers. Okay. So it's a bitwise operation. All right. And any value in between, if you put 120, 130, 240, whatever, it may give you some color, brown, green, whatever, right? You will get various colors. That's all it is. But to achieve this, we need this structure called multidimensional array, which in NumPy is called ND array. Okay, n-dimensional array. Okay. Please attempt these quizzes now, guys. There are 2 quizzes. Both are on your screen. Attempt it. And any volunteer can just put the answer in the chat, right? Consider this list. I've already given the list here. Just copy paste into the cell. What happens when you convert to NumPy array? Can anyone tell me? Okay, Anshul gave me an answer. Others? It's this one. This quiz is pretty simple, right? You just copy this list, put here np dot array, and then put the list, and then execute. What is happening? I have raised hand. Sonal, is it a misclick or this is second time? Hello? Cannot hear you, Sonal. Hello. Put in the chat. I can't hear you. There's some problem. No, Sonal, there's some issue. Others, what's happening? Did we run this? Okay, let me just run this here. Now, Anshul says he's getting an array. I don't know how. Because you'll get an error. Of course, you'll get an array, right? But what will happen is that the requested array has an inhomogeneous shape after one dimension. This means, and see this very carefully, okay? You have here 1, 2, 3, 4, 5 elements, and you have here 1, 2, 3, 4 elements. Typically, yeah, you'll get an error, correct. Typically, guys, if you're getting an error, put in the chat. Don't worry, okay? Programming is all about error and debugging, okay? So, yeah. Why this is happening error? Because NumPy is telling you that you cannot have different length row and column. What you going to have in the missing value then? Because array is trying to convert it into a graph. Yeah. So, ChatGPT will give you that. Yeah. So, I can't answer whether ChatGPT is able to understand error. In fact, Anshul, you can just take this error and put it in ChatGPT. Try it, right? Take the error and put it in ChatGPT. Then it will tell you. Then ChatGPT will tell you, oh, the dimension should match. Okay, ChatGPT is like that. You need to keep giving push. Okay. Yeah, dimensions are not matching. The whole point of NumPy array is that it's a very strictly mathematical object. A matrix should have all the values. You cannot have 4 elements in the first row and 3 elements in second row. You cannot have 5 elements in the first row, 4 elements in second row. Why? Again, I told you this very basic fundamental object called NumPy array is used everywhere, right? Yes, Mahalakshmi, correct. You will get error. Two files, np import np. I don't know what happened, but just import NumPy as np again. Sure whether there's an issue, but you can just import NumPy as np and check. N cross m equal to n cross m. Okay. Yeah. All right. So the whole point is that your things like pandas, things like machine learning, and all of these data analysis, ML stuff, right? It assumes a certain structure of your data. Okay, so you cannot have randomly varying data types, varying sizes of data, and then call it a structured data. Okay, unstructured data is different, by the way. Unstructured data will be like text data, document, all that is a different kind of data analysis. But now we are talking about structured data, and this is the strictest structure that we have. Okay, NumPy arrays. What about this? And I mean, this is again simple answer, right? You just take this list and just put here np dot array, put the list, and how many dimensions are we getting? Clearly I can see 2 dimensions, correct? You can see the rows and you can see the columns. Okay, these are all very simple quizzes to motivate what's going on here. All right, so here as you can see, -1 1, this became my first row, 0 1, this became my second row, but it's not a single line anymore. They are placed on top of each other correctly. Okay, so you have the first column -1 0 and the second column 1 1. All right, so yeah, 2 dimension, correct. This is 2 dimension. And by the way, number of dimensions you can just check here. Okay, so how many square brackets are there in the beginning? That's how I check quickly. But of course there's a more easier way to check, which we'll study soon, which are the attributes. All right, so what we've seen is we understood that NumPy arrays are essentially multidimensional in nature. It is able to store any number of dimensions. I have shown you 1D, 2D, 3D. You can store 4D, 5D, 6D, wherever. Any type of n number of dimensions you can store, and it can handle that kind of complex data, which is not required for us, by the way. Throughout this program, mostly we will stick to 2D, maybe 3D in a few places, right? Now that we've studied NumPy arrays to some extent, and we have some familiarity with these things, let's look at some of the attributes. As I told you, whenever you instantiate a class, right, into an object, you will get many attributes and functions associated with that object. Okay, so one specific object like that is the NumPy array. So for example, suppose I have this 1 minus 1 and 0 1. I'll convert to array. Obviously 1 minus 1 is the first row and 0 1 is the second row. So there is this attribute called ndim, okay, which tells me the number of dimensions. So you take the object npr dot ndim. It is an attribute. Okay, so you don't need to put brackets like this. It's an attribute. So if you just run ndim, it will give you the number of dimensions. 2, obviously 2. I have 2 rows, 2 columns. Obviously it's just rows and columns. It doesn't have depth, right? You have x, you have y. You don't have z. Okay. Now what about this image thing? This image, already we have the hint here. If you see on the top where it starts, there are 3 brackets, which means it should be 3 dimension. And if you just do image.ndim, you will get 3. Okay, this is 3 dimensional. What about this? The stuff that we were learning in example number 1 in section number 1. So here you have a single list, right? It's not a list within a list, it's a single list. And suppose I convert it to array, what will be the ndim? Obviously it should be 1 dimensional array. So this has only 1 dimension. Think of it like number line, right? Your number line is a single dimension. This thing has 2 dimensions, x and y. The image obviously has 3 dimensions. What are the 3 dimensions in the image, by the way? It's the rows and the columns, and then the channels. I told you red, green, blue. There are 3 channels. Okay. So ndim quickly gives you the number of dimensions. It's a fairly simple attribute. One of the most important attributes in NumPy array and everything else in the future, pandas, whatever, is shape. This shape thing, if you get it correctly, then half of data analysis you got, right? If you understand the shape business. So suppose I have a list within a list. What is this going to be? This is obviously going to be 2 dimensional, correct? So I have apple, banana in my first row, and I have cherry and date in the second row. Obviously 2 dimensional. Okay, so apple, cherry first column, apple, banana first row, banana, date second column, so on and so forth. And ndim is obviously 2, right? So if I just say np air dot ndim, we know that it should be 2. There's this attribute called shape, which is quite the important attribute. It tells you the length of each dimension. It's telling you how many items are there in each dimension. So suppose instead of apple, banana, I do apple, banana, cake, and instead of cherry and date, I do cherry, date, eagle. I don't know why eagle, but whatever. So I have now 3 3. Okay, endim is still 2. Number of dimension is obviously 2. You have row, you have column. You can see that here. Row is one kind of dimension, column is another kind of dimension, right? X, Y. But what is the shape? Now if you see, the shape is 2 3. What it's telling you is you have 2 rows and 3 columns, basically, right? The shape is telling you how many items are there if you look at a certain axis. If you're looking at the rows, then you have 2 items. This thing is 1 item, this thing is 1 item. If you're looking at the column, you have 3 items. Apple cherry is 1 item, banana date is 1 item, cake eagle is 1 item. 1 2 3. So shape actually tells you how many or the length of each of the dimension. Okay, and by the way, how many items are there in this shape output? I hope everybody is able to see that this is a tuple. Okay, this shape business, this is a tuple. What is the length of this tuple? Obviously it should be equal to endim. Okay, so if I just do length of shape, in this case I will get 2, and endim is obviously 2. Why is it 2? Because there are 2 dimensions. So whatever values you have inside, which is the length of each dimension, how many such length should you find in your shape? Equal to number of dimension. If you had 3 dimension, then you will get 3 values. Okay, so the shape attribute is something that we will encounter again and again. Okay, in this session, matplotlib, elsewhere also, shape is very important because it tells you how much data you have. It's exactly telling you how much data you have, how many rows you have, how many columns you have, which is, I guess, the most important thing, right? Anyway, so we all know how to access items from tuples, right? Indexing we have already learned. So please use this shape attribute and solve the first question. It says extract the size of the array, np.array, this one, in its first dimension. How would you do this? Please try it. I might just do it like this. I want to, yeah. Lakshmi is showing error. What is showing error? Import NumPy as NP showing error for you. Like, just reset your notebook, open it again if you want. Others, please solve this quiz. Please use the shape command and pull out the size in the first dimension. Lakshmi, can you tell me, is it working or still error or what? I didn't see the chat, sorry, I was still error. What is giving error? Import NumPy as NP, this simple statement is giving you error? Anusha, I pull out the first element from that tuple. You're almost there. So here I will do dot shape. And what is the size of the first dimension? In other words, how many rows do you have? Like, if I have to rephrase the question, how many rows do you have? I mean, you can immediately see 1, 2, 3 rows. I know. The way to do is you just do shape 0. Print array shape, array np array print array shape, print len array shape. Abhishek, you are getting the length of the shape attribute. What you should get is the number of rows. Okay. So what it's saying here is size of the array in the first dimension. First dimension means row. Okay. So if I just do shape, if I just do here shape, I will get 3, 4 because it has 1, 2, 3 rows, right? And then when you put it on top of each other, you will get 4 columns. So that also we can just print here and show, right? If you just print this, I have 4 columns and 3 rows. That is visible, right? We can easily see there are 3 rows and 4 columns. But what is the size of this array in the rows? That is first dimension, that is rows. So for that, I will use dot shape, right? Because I cannot use length. If I just do length of this thing, right? Length of this NumPy array. Let's now continue with accessing elements. Okay. So we won't spend too much time on 1D because I think we are all aware. I'm just going to revise. So here, if you see, I have a one-dimensional list of numbers and convert to array. So clearly this is one-dimensional. So you can check ndim and all that, np air.endIm, that should be 1, right? And here you can use length, right? That's not a problem. Here you can use length. You can also use shape, right? np air.shape. Notice that the shape is still a tuple, by the way. That's how strict NumPy is. Even if your array is 1D, shape will output tuple. So if you want length, you have to do shape 0 again. Okay. Anyway, so how do you pull out element from this? Now we've already done indexing in lists. So for example, what does npr2 do? It will give me the third element, right? 0, 1, 2. This should give me 32. Okay. What is 1 to 4 going to do? 1:4. It will generate 1, 2, 3. And 1, 2, 3 for me is minus 36, 32, 47. Okay? Minus 36, 32, 47. What will happen now? You can also index it, not contiguously, right? You can just put the elements that you want using commas. So np array, if you do 1, 2, 3 inside a list, that will still give you the same array, minus 36, 32, 47. All of these is very similar to lists. Okay. Here you have open-ended. So 2 colon nothing, that means 2 to end. Okay. So 2 is 0, 1, 2. So 32, 47, 71 minus 45. 32, 47, 71 minus 45. And so on. Right. We remember all this. And by the way, 6 I think is the length of this array. So if I do here 2 to 6, I will still get this. I can also do 2 and then use length command to go to the last element, right? Which will still give me this from starting from the third element, 0, 1, 2, 32 to minus 45. You can also use, :3, which will give me up to the second element, third element, 0, 1, 2. Okay, so this will give me 22 minus 36, 32. And you can do the same using 0. Instead of not putting anything here, you can put 0. It will count 0. 0, 1, 2 gives the same result. Minus 1, I hope we remember what this negative indexing does. Minus 1 gives me the last element. Okay, so if you do minus 2, it will give me second last element. Cyclic indexing, right? What will happen if you do :-1? It will give everything up to the second last element, right? It will exclude this and give me everything up to. So 22 to 71. And if you do np array :-2, what's it going to do? It's going to skip the last 2 and it will give 22 to 47, right? So these are all very similar to lists. I've kept a homework here. Not going to spend too much time on this. Reversing of a 1D array. You have reversed lists before, so you can solve this on your own. Now, this is where the funny business starts. Okay, 1D array element access was simple. Obviously, accessing 2D, 3D arrays is going to be slightly more complicated, right? Now I have here 1, 2, 3, 4, 5, 6. This is our very friendly 2-dimensional array. It has 2 columns. It has 2 rows, and 3 columns. Now, I'm just going to show you level-wise access. So if I do here np array 0, notice that it gives me the first row. Okay. Now, if I want the first element in the first row, then I do np array 0 and then 0. Okay. So if you do this, this will give me the element 1. If you change this to 1, this will give me element 2. If you change this to 2, this will give me element 3. If you change this to 3, it will give error. Because obviously it's out of bounds. You only have 0, 1, 2. Only 3 is the length of the each row, which you can get from shape also, by the way. Number of columns is 3. So you cannot access 3, which is the fourth column. Doesn't exist. Okay. So if you want now second row, what do you do? np array 1. This gives you second row. So now in this you can also do first element is 0, second element you will get 1, you will get 5, and then if you do 2 here you will get 6. Okay. Another way of accessing is comma. So instead of doing bracket, if you want the first element here, which is 1, you can do 0, 0. That will give you 1. So if you do 0, 1, you will get 2. Okay, so this is a tuple, isn't it? In Python, when you do 0, something, I mean, if you do something, something, that's a tuple. So NumPy array accessing allows for tuples. Here it's a tuple because it's a 2-dimensional array. Okay. Otherwise, the tuple will fail. And for 3-dimensional array, you can have 3 numbers. We will see 3-dimensional soon. So similarly, if you want the second row and third column, So as I showed you before, second row, third column, 6. Okay, second row, third column is 6. Okay, now if you see the shape of the first row, that's 3. That number of columns is 3. We already discussed this. You can also, access arrays while maintaining the shape of the array. That is something very interesting in NumPy. So here, if you do np.array 0 like this, you will get the first row. Okay, but if you notice that it is a one-dimensional array. If you see the list here, it has only one bracket. The same thing if I put 2 brackets like this and access the first row, I will get 2 list brackets here. And if you see the shape, it will say 1,3. Interesting. So np array 0 gave me a one-dimensional array of length 3. Obviously, right? 3 items, 1, 2, 3. But np array 0 with 2 list indexing parentheses will give me a 2-dimensional array, which is why the shape is 1,3, and you can see 2 list brackets here. So this is a 2-dimensional array with 1 row and 3 columns. But this is a one-dimensional array with only 3 elements. Okay, this is one way of accessing things in different ways. Now you can of course also access the same slicing which we've learned in lists and things like that. So 0 colon is going to give me 0 till end. In my case it is 0 and 1, right? Now what is this? What is this kind of indexing? So this is obviously telling take the first row. Okay, this means give me all the columns. So if you do this, you will get the first row and all the columns 1, 2, 3. Okay, what happens if you don't specify anything? You still get the same thing. So if you do 0 comma and just leave it, right, you are essentially calling the first row. So this is one way again to access the first row. You can also do this, right, np array first row and then do this colon here, right? This also means give me all the columns. So same way you can now slice the columns. So what does npr 0 and then 1 colon mean? This means get the first row and then in the first row start with the second column. Please remember Python is slightly like that. 1 means second item, 0 means first item, correct? So npr 0 means first row. Okay, and then the second indexer says start from second column till the end. I will get first row, which is 1, 2, 3, start from second column till the end, 2 and 3. So you can see the answer here is 2 and 3. Okay, please try solving this quiz and I want to see some answer in the chat. I'll try to print it here. Okay, hey Mahalakshmi, didn't see that. Thanks Anusha for sharing the link. Okay, guys, please solve this quiz and give me your code in the chat. And please don't go to ChatGPT for everything, okay? This should be very simple. I've taught you all these access techniques. Just declare the array in your answer here. And, how will you print fig? Where is fig? Just access it and give me a code, please. Correct? So second row, I came here. Second column is this element here, fig. Perfect. So obviously, you can use multiple access methods. You can do 1, 1. You can do 1, 1, right? There are many ways to access this, and I urge everyone to try various access methods. Okay, which is why I have a lot of practice questions for you guys here. I'll not solve these right now. Please don't solve these right now. Okay, there's lots more to cover. You can go through these questions. These are all the same array, right? Same array is here. I'm asking you to print lemon, print kiwi, lemon, mango, print banana, cherry, whatever. Okay, great. Now we'll move on to all right. Abhishek is giving other answer. Okay, we are moving on to 3D arrays, guys. Okay, so as I was saying, the shape of this image array right now, obviously it has 3 dimensions, and here it says 25, 32, 3. Right. So what you're seeing is, so if you see one full list here, this is of the shape 25, 32. Okay, it is showing you 25, 32, 25, 32, like that is showing, and there are 3 such channels. So basically now what will happen if I do image of 0? What is image of 0? Image of 0 is nothing but the first row, but it will show you all the columns and all the channels. So I have 32 columns and I have 3 channels, right? I have 25 rows in my image, and if you want, you can show the image here. Let me see. Right? Was it root value? 1 second. Oh, sorry, I am show. plt dot I am show image. Yeah. So I have, if you can see, the axis actually shows 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 25. And then you can see 0, 1, 2, 3, 4, 5, 6 till 32. Okay. So obviously it has 25 rows here, right? And 30 columns. And each intersection you can actually see the square. See, everywhere you can see square, small squares. So each square is one number. Okay. So if I just say img 0, it is going to give me the first row, all of these. So I have dark blue, light blue, whatever. I have these 32 squares here, but it's going to give me 32 squares of red channel, green channel, and blue channel. So totally I will be having 96 elements here. So if you just check the shape of img 0, which is only the first row, shape of the first row of this object only. Okay. So img 0 shape, it is 32 by 3. As I said, it is 32 columns and 3 channels, RGB. So you're getting 32 3. Now if you want to maintain the original shape, then you just use the double brackets and pull out the row. In this case, see, you will get 3 brackets. It's the same information, right? 0, 62 176, 268 181, all these things, same thing is here, right? But now you have 3 brackets, which means that you are retaining the original shape of the object, which is 3 dimensional. So here if you do img double bracket 0 dot shape, you will get 1 row, 32 columns, 3 channels. Now very similar kind of access method works here also. So if I do image 0 0, what is going to happen? It's going to give me first row, first column. Okay. By the way, the first column is here and the first row is here. For images, everything starts at the top left. Okay. So this blue color pixel here, that is the object I'm going to extract, img 0 0. So if I just do img 0 0, what I should get? I will get 3 dimensions. Okay, RGB. Very interestingly, just as a side point, see, the value of blue is high. Okay, and the value of green is okay. Value of red is 0. So these are your RGB values for the first pixel, where this one. And it should be very intuitive that dark blue color should have a high value in blue and moderate value in green, and obviously will not have so much value in red. So this is the 3 channels which you cannot see in the image. It is in the 3rd dimension, right? You cannot see it, but you can extract and see for yourself that these 3 values are there for the first pixel. Now if you want only the red channel value, then just img 0 0 0. That's it. Whatever you did in 2, you're doing here also. One interesting thing is that this kind of accessing will not work, right? So here you expect how would you expect this to work? The way to read this would be img of first row, all columns, 32 columns, and the first channel, which is red channel. That means you should get a 32 length array, but you are not getting. Okay, so this kind of accessing ceases to work. Okay, if you use even a combination of comma and this kind of indexing, still you will not get what you're looking for. The best way is to use commas. So in 3D array, if I wanted all 32 columns, now you can see this is length 32. Okay, so what's happening here? This is the red channel, which means just imagine the image to be like a sandwich, red and then behind green and then behind blue. So what I'm pulling out here is the red channel, the first channel, the first row of the pixels, and all the columns, right? So I am getting all of these values in the red channel. Okay, so I will get 32 values of the red channel. So I think it's becoming clear that the reason that this thing is called numerical Python is because it's a very powerful attempt to try to structureize mathematical structures like matrices, n-dimensional structures, things like that, right? It's not so easy to imagine. Right now with images, it is somewhat easy to imagine. Okay, I have row, I have column, I have channel, right? So it's somewhat easy to imagine. When you work with slightly more complex stuff like some ML models, things like that, then you need to start understanding the math behind it. Okay, at this stage, just getting a familiarity for it is more than enough. Okay, you can obviously use slicing. I'm not going to go more into this. It's all the same, right? This means what? 0, 1, 2. Start from the third row. What does 4 to 9 means? 4, 5, 6, 7, 8. Give me from 4 to 8th column. And then what does up to 2 means? 0 and 1, right? So it's just going to give you that piece of the n dimensional array. Okay, cool. Yes, Akash, like this, the green and blue will have some value. Yes, try it out. Okay, try it out. See, the idea of this session is to enable and empower you guys. Okay, we are discussing all the different basic and fundamental methods related to NumPy. And then you guys, all of these practice questions are available. And on top of that, please feel free to explore. Okay, I'm using some very bad resolution image. Use a good image and see. No problem. Okay. Now this is something that you may have seen before, Boolean indexing. It's nothing but extracting or accessing element based on condition. Okay. So for example, let's continue with our two-dimensional array, 1, 2, 3, 4, 5, 6, 2 rows, 3 columns. What will happen if I just say condition NP array greater than 2? So this is essentially going to give me an array. So when you put NP array greater than 2, see, is 1 greater than 2? False. Is 2 greater than 2? False. Is 3 greater than true? Yes, true. Is 4 greater than 2? True. So it gives me the Boolean value for each of the indices when you apply a condition. Now you can use this Boolean index array to index the array. So you take this condition and then just index the array. It will give you the values which satisfy the condition. One thing you should note is that the shape is destroyed. Obviously the shape will be destroyed, because when you do conditional access, are you ensuring that you maintain the same number of elements? No, obviously not. In conditional access, you just want some elements and not other elements. So when you conditionally access a NumPy array, it collapses to one dimension. Why? Because we know if you do 2D or 3D and there are missing elements, then there will be an error. So to prevent the error, it collapses to one dimension. Okay. All right. So one thing you also need to understand is that these are not in place operations, because even after doing all this conditional access, if I print my NP array, it is still the same array. Same array, obviously. This is not in place. So in Python, most of the manipulation that you do will give you an output, but it will not disturb the original object. So here I've done conditional access on NP array, right? NPR. It has given me, it has collapsed my original array into a 1D array, and it has retained every value greater than 2. Okay. Did my original array change? No. Try printing. Your original array did not change. So if you really want to replace your original array, then you have to assign it, right? So you take this collapsed version and assign it to a variable. And in that case, your original array will be rewritten. I don't want that. So I'm going to redefine my original array again. Now we can also see more complex logical conditions. So greater than 2, we know it's going to give false, false, true, true, true. Okay. Less than 5, what is less than 5? 1, 2, 3, 4. These are less than 5. So true, 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 and the other two false. And logical conditions you may have seen before. Just and means both should be true. We know that. And or means either or, right? Either this is true or that is true. One thing to note here is that if you do not put the brackets, then there is ambiguity in the logical condition. So if you put NPR greater than 2 and NPR less than 5, you will get ambiguity. So it's written here, see, truth value with more than one element is ambiguous. You're learning right now, practice over time. And one fine day when you're doing course number 3, all this will be like, I know everything. Anyone wants to share the answer in the chat, the code? What are the steps here? Very simple. ठीक है 60 लगा लो, you might get 13, no problem. No, 60 में 12 आ रहा है. Taker, greater than 60, I'm getting 12, man. Question says 50, by the way. Others, have you solved the quizzes? No, please code it. The whole point of this session is for you guys to code along some of these quizzes and see the results. I hope, is everyone doing the quizzes or not? And it's, I mean, maybe I didn't make myself clear. It's written here, code here. Use what you're learning here and practice. Code and find out. Yeah, this is perfect, Pratim. This is perfect. Let me just copy Pratim's answer and see. So Pratim has done NumPy arrays this L equal to len print L. 14, correct. Yeah, 14 is correct. Okay, great. Next quiz. Load the sun image JPG into an array. I think the array is already accessible. So, just print img. So you don't need to load again and again. If you have been following the code till now, if you've been running it. Oh, okay. If you've been running it till now and following the session, then this img array should be available to you. If not, just run the matplotlib import and image load code. Okay, what we need is the array. Now what I want you guys to do is count the number of pixels in the red channel of the image whose gray level means value. Okay, don't worry about gray level, it just means value. Okay, count the number of pixels in the red channel whose value are within 25 and 255 both inclusive. Can I get a code for this? So red channel means, how do you access the red channel? Anyone? Red channel means the first channel, right? But how do you access it? What is the way to access? Any volunteers? So red channel means what? It's the first diamond. It's the first slice in the third dimension. Think of that way. So when I access, the first number is the number of rows. The second number is the number of columns. The third one is the depth. So the question says, obtain the red channel, which means I need all the rows. So I put colon. I need all the columns. So I put another colon. And then red channel is the first channel in the third dimension. So I put 0. This will give you the full image in the red channel. Okay, so you can see here. And if you do dot shape, you will get 2532. So out of the 3 channels, RGB, which was 3, if you remember, shape had a third element 3. Now we have only the red channel, which is 0. Okay. Okay. Suppose I store this in red image equal to. Okay. So I have my red channel. How should I count the number of pixels in my red channel whose values are within 25 to 55 both inclusive? Simple conditions. So I need red image greater than equal to 25 and I need red image less than equal to 225. These are the conditions, right? So within 25 to 25 both inclusive means what? Greater than 225 and should be less than 225. This is my logical condition. This I will use to access the values from the red image variable. So red image and then access it using this Boolean condition. So this will give me all the pixels which are between 25 to 55. Now check the values. Once you run this command, check all the values 39, 28, 26, right? So you will get all the values which are within 25 and 225. You will not get 24, you will not get 226. All these values satisfy this condition. Now if I want the length, I can just find length of this object, which is 545, or I can do shape and then extract, or I can do directly shape, but it will give me a tuple. So if you want the element, you just do shape of 0. Okay. So what did we learn in this quiz? Accessing. Okay, accessing from multidimensional arrays, you need to be careful, and the best way, as I've mentioned, is commas. So this colon means what? It means all the rows. This column means what? All the columns. The 0 means what? Only the first slice from the third dimension. Now the third dimension has 3 slices, right? So I'm getting only the first slice. Red is the first slice, by the way. Green is the second slice. Blue is the third slice. So 0, 1, 2. All right. Yeah, R is 0. R is 0. G is 1 and B is 2. Good question. Answer in the chat. R is 0. G is 1. B is 2. 3 values, 3 slices. Which is why your shape third element says 3. The length, the size of that third dimension has 3 slices. Okay. 0, 1 and 2 are the indexers for that. Okay. Again, there are a couple of homework questions here which should not be hard to solve. Okay, you can try it out. Again, this is Boolean indexing. Okay, so use and conditions, things like that. And there's a very interesting question here. Try to see when you can solve later. Try to see what happens here. Okay. So basically, what we've learned till now is we've learned how to declare arrays. We've learned 1D, 2D, 3D, n-dimensional arrays. We understood that actually, if you see the 4-dimensional, 5-dimensional arrays, we can't even imagine, by the way. There's no visuals for 4-dimensional, 5-dimensional array. There is no visual. Mathematical constructs. Up to 3 dimension, there is, something we can do. Humans can visualize up to 3 dimension. 2 dimension, rows and columns. 3rd dimension being depth. More than that, it's hard for humans to visualize. But the NumPy array class allows for any number of dimensions. Okay. So that's very interesting. As I said, mostly we'll be working with 2D, 3D arrays invisibly. So anyone who is getting kind of, oh no, do I have to keep looking at these array slices and all? No, you don't, because all of this stuff is used in the back end of many data analysis, data science, and machine learning techniques. What I need from you guys is to understand this to some extent, right? That is the main, say, outcome, okay, of the session. So there are a couple of other methods here, that I've mentioned. I've given some hints here. Okay, there is a method called numpy.where. There's a method called numpy.nonzero. Try exploring these, solve it however you can, use help of GPT and see. Okay. Now moving on. Operations on NumPy arrays. Okay, so we've seen declaration, size, attributes, things like that. One of the key features of NumPy is the ability to perform vectorized operations. Okay, so it's faster than for loops, basically. Okay, suppose, for example, first we'll do some simple operations like append. This should be very clear, right? How to add elements. So if I have an array 1, 2, 3, the append method in NumPy, it has 2 important parameters. One is the original array on which you want to do the appending. The other is the value that you want to append. So my input array is npr, which is this value here, 1, 2, 3, this array, and value I want to append 4. So if I just do np.append, give the input array, give the appending value. Now you will get array 1, 2, 3, 4. Notice if you print original np array, it is not disturbed. Okay. Again, remember, many of these operations will not be in place. They will be temporary. The output is temporary. Okay. So the original object is not changed. If you really want to change the original object, you need to assign. Okay. So now in this case, np.append, and each time you don't need to provide the name of the parameter as long as you provide the values in the correct order. So here I'm providing np array and 4. So, and I'm changing the original, by the way. So I'm doing append np array with 4 and then store it in np array itself. So now your original object itself will change. So here we have seen appending one integer or one value. You can obviously append list-like objects to arrays. So if you want to append more than one, right? So right now the array is 1, 2, 3, 4. So this thing np array right now is 1, 2, 3, 4. I can even append 5, 6. So it's going to append 2 more elements. So if I do that, I'll get 1, 2, 3, 4, 5, 6. See how seamlessly it goes in, appends, and sits in the array. Okay. And this is obviously a list, not an array. The thing you're appending is a list. You can append a list. You can append an array also. So right now my array is 1, 2, 3, 4, 5, 6, which is my array here. Let me append np array 7, 8. What is the output? Again, very seamlessly it goes in 1, 2, 3, 4, 5, 6, 7, 8, appended very easily. Okay. Deleting and removing elements is something we will not worry too much about, but it's good to know. Okay, so for example, right now my array is 1, 2, 3, 4, 5, 6, 7, 8. The method used is np.delete. It's very similar to append. Okay, you put your input array here. The only thing here is that in append you give values. Okay, in delete the parameter is called object. It is the actual object that you want to delete. So if I do np delete array equal to np array and object equal to 2, then what will happen is the sorry, it's not the actual object, it's the index. Okay, it's the index of the object that you want to delete. So here if you see, the index is 0, 1 and 2. Okay, that's the difference between append and delete. In append, when you append the value, you are providing the actual object. In delete, you can't provide the actual object because objects can repeat. So if it's like 2, 3, 4 and then 2, 3, 4, which 2 or which 3 should I delete? So obj, and I know it sounds very counterintuitive. Why would they call it object? They can call it something else, right? Index or whatever. But that's how it is. Okay, the parameter name is object. I guess it means object number 2, right? So object number 2 in Python language is 0, 1, 2. So this 3 will get deleted. Again, this is not an in-place operation, which means your original array will not be disturbed. If you really want to delete from original, assign it. Okay, so in this case, I have assigned it to np array, and the second, which means the third object with index 2, has been deleted. 0, 1, 2, 3 has been deleted. You can also delete multiple objects, so you can give the indices here, right? So in this array, if I say object 0, 2, 0 means what? It's this 1. 2 means what? Right now it is 0, 1, 2, which is 4. So ideally 1 and 4 should get deleted. If you see in the output, 1 and 4 got deleted. You have 2, 5, 6, 7, 8. Okay. And I mean, of course, you can continue the same, and this is how delete works for 1D arrays. Okay. Replacing is very simple. It's a simple equal to sign. Okay. And by the way, I'm using the word assignment. You can even use the word equal to. That's what is going on here. But in programming language, equal to means assignment. Okay. Equal to means equal to, right? So if you have double equal to, that is the mathematical equality condition. Equal to means assignment in programming. So suppose I have this NumPy array here, 0, 2, 4, 6, 8 and so on. If you want to replace some element, just index that position. So np array 1 means what? It is the object 2. Just assign 5 and 2 will change to 5. Very simple, right? You can directly assign objects into the array. You can replace elements like that. Of course, you can replace sections of the array also. This also you can do, not just one by one. So np array 0 to 2 means what? Right now my array is like this. What does 0 to 2 meaning? 0 to 2 means 0 and 1. So 0 to 2 means 0 and 1, up to 2 excluding 2. So these two, 0 and 5. I can replace these two with two more numbers, -1 and -2. So it's a list. You can run this. So 0 and 5 will be replaced by -1 and -2. Okay. And I can also, do indexing, slicing, all the usual stuff, right? However you want, you can access the array. So -2 colon means what, right? It means that from the last two. Okay. So -2 colon, it means from the second last up to the end. So -6, -4. These two will be replaced with these two, 100 and 200. All right. So I've given a few quizzes here. I won't go more into this. These are quite simple operations, which if you practice and sort of see, you'll get better at. So for one dimensional, at least, I'll not be, going into the quizzes right now. So they're all homework. You can try these on your own. Okay. Now, 2D. This is where the interesting stuff starts, right? So one dimensional, we know it's very easy, right? Two dimensional is where we need to be a little careful. Okay. So let me declare an array. Okay. This is two-dimensional array, obviously. 1, 2, 3, 4, -4, -3, -2, -1. So I have 2 rows, I have 4 columns. You can check the shape. 2 rows, 4 columns, and totally 2 dimensions. Now, if I just say np.append and I use np-array, 0, what is the output? Let us see. Interestingly enough, it collapses to one dimension. Okay, so if you append an integer to one-dimensional array, no problem. But if you append an integer to two-dimensional array, the array collapses into one-dimensional because NumPy doesn't know where to add. Okay, NumPy has no idea where to add. So it collapses this thing into one-dimensional array and then adds the 0. Again, notice this is not in place. Okay, it is a temporary output. So your original object is still there. Okay, let us say, I will use the same command, np-array and 0. There is something called axis, right? And by now we know what axis means. Axis is nothing but the position of the dimension you're looking at. So I am using the word dimension. Axis is just another word for dimension. So somebody asked, for example, right, if my image, suppose I have image.shape, right? So I have these 3 dimensions, basically 3 axes, right? X is one axis, Y is one axis, Z is one axis. Okay. The first axis will be here, 0th axis, right, in Python language. And then the first axis is here, second axis is here, totally 3. So what does axis equal to 0 mean? It means row. So right now, 1, 2, 3, 4 is the first row, -4, -3, -2, -1 is the second row. What will happen if I append this array with a 0 and I specify axis 0? Interestingly enough, there's an error. Why it is error? Because this is an integer. Okay. And what you're trying to append in the row, if you append here, what will happen to the second row? Just think about it. If you append this to the first row, what will happen to second row? There's nothing to be appended to second row. Again, this is going against the structure of the NumPy array. See how restrictive this thing is, which is also good because it's a very foolproof and very safe object, right? NumPy objects are very safe, right? You cannot do random changes like this. Okay, so let's go back to one dimensional. Okay, so here if you have a new array, suppose we'll come back to this. Let's go to one dimensional. -5, 2, 5, 7. I just have a random array here. See the shape right now. Okay, we know that the shape is a tuple. Right now it is 4, nothing. The number of numbers in the shape is 1, which means it is one dimensional. If I append, I am getting an error. Very, very interesting, right? What am I appending? I am appending np array with new array. So this array, right, 1, 2, 3, 4, -4, -3, -2, -1. This array I am appending with this array. Okay, so what do you think should happen? This -5 to 5, 7, it should come below here. Then it'll look nice, right? I'm appending this row here. What went wrong? What went wrong in this, right? Axis equal to 0 means row. So if I have a new row and I'm specifying axis equal to 0, why is the row not being added? That's because of a mismatch in shape. If you see the shape of the original NP array, that is 2, 4, it has 2 values, 2, 4. If you see the shape of this new array, it is 4, nothing. It has only one number. So in terms of ndim, np array.ndim is 2 and new array.ndim is 1. The dimensions are not matching. Even though for us it looks like, okay, -5, 2, 5, 7, it should just come beneath this. It should come like the third row, right? But for NumPy, it's not like that. The dimensions need to match. Okay, which is where there is a very important method called reshape, which is used to handle these kinds of problems. So right now, your new array is of the shape 4, nothing. It has only one dimension. I need to reshape into what? If you want to add -5, 2, 5, 7 as the third row here, then what should be the shape? It should be 1 row, 4 columns. Right now, my NP array is 2 rows, 4 columns. How to add another row here? That thing, the new row should be 1 row, 4 columns. That 1 is missing in the shape right now. The way to bring it is reshape. So there is a method called reshape and you give the new shape inside the bracket. So what is the new shape that you want? You want 1 row, 4 columns. So when you do this, notice suddenly you have 2 list brackets. Above, if you see new array, it had only 1 list bracket. It's a one-dimensional object. Now the shape matches. Okay, now the shape matches. Again, just to show you, this is not an in-place method. This is a temporary output. So you need to assign it. Okay, so let's go ahead and assign new array dot reshape 1, 4 to new array. Okay, so it's the same object, but then notice how the structure is different. Okay, in one case it was a single dimensional object with 4 objects, -5, 2, 5, 7. In this case it is actually a 2-dimensional object with 1 row and 4 columns. That's how strictly you need to match the shapes. Okay, so let me go ahead and reshape and assign. Okay, so now my new array is overwritten with the reshaped version. Now if you check the shape, you will get 1, 4. Initial shape was 4, 1-dimensional. Now it is 2-dimensional. Now you try to append. Okay, after all of this hard work, now we'll try to append NP array, which is this one, 1, 2, 3, 4, -4, -3, that one, with new array, which is -5, 2, 5, 7. Which dimension do you want to append? I want to append as a row. So axis equal to 0. To finally run this, and now you are able to append -5, 2, 5, 7 to the array. And I have assigned it, so my original array has changed. Okay, what do you think the shape should be right now? 1, 2, 3, 3 rows and 4 columns. So if you do np-array.shape, now you get 3 rows and 4 columns. So the moral of the story here is shape is very important when you're trying to work with NumPy arrays, right? In very mathematical terms, what we are talking about are finite values on various axes. So you have x-axis, y-axis, z-axis, whatever, and we have different values on these axes. That's exactly what is being represented here. Okay, and if you remember some kind of high school maths, suppose vector or something, right? If I have a vector 2, 3, 5, which is a coordinate point, I cannot show that in 2-dimensional graph. Same way, if I have a point 2, 3 in 2-dimensional graph, it's not a point in 3 dimension at all. Where is it in 3 dimension? The 3rd dimension information is missing. So that's how strictly the shape and structure of these arrays is maintained, okay, in Python. As another example, suppose I have a list of lists, and this thing, if you see, the first row is just 2, second row is -3, third row is 4. This is a column vector, basically, right? This is called a column vector. What do you think the shape is here? By now, I think we should be very comfortable with shape. If you look at this, it says 1, 2, 3, 3 rows. I see 2 list brackets, so ndim is 2. So the shape must be 3 cross 1, correct? Cross 1 column. So let me just check that. New array dot shape 3, 1. Okay. Now let me try appending this to this. What do you think should happen? See, right now the shape here is 3, 4. Right? It has 3 rows and 4 columns. And now I have a column vector of the shape 3, 1. Right? It will append as a column. So you will get 4, and after that you will get 2, -1, after that you will get -3, 4, after that you will get 7. So let's see. And yeah, you have to specify the axis in which you are appending. So here, if you just change axis to 0 and you append this column vector here, that's not going to work. You're going to get error, dimension mismatch. This error, okay, as you go through this program, this error will come so many times. Okay, whatever you're working with, pandas and everything else, this dimension and shape mismatch error is something that you will quite frequently encounter. Okay, so here I need to specify axis as 1. Okay, column. So if I do this, 4, and then this 2 got appended as a new column here, and then I have -1, and then -3 got appended here. Similarly, I have 7, and then 4 got appended here. Now what is the shape of this array? Obviously 1, 2, 3 cross 5, 3, 5. Okay. Similarly, suppose now I have, let me just expand it even further. So now I have 5, 9 first row, -4, -2 second row, 7, 1 third row. So this is obviously, and I've used 2 brackets, by the way. So this is 3 cross 2. Right now it is 3 cross 2 array. And this thing is 3 cross 5. So 3, 3 matching, right? Number of rows is matching. Number of dimensions also matching. Here you have 2 dimension. Here also you have 2 dimension. So 5 columns And now if I append this one with this one and specify access equal to 1, I will get 5 plus 2 more columns. I should get 7 columns. As you can see here, 5, 9 has appended here to this row, -4, -2 appended here, 7, 1 appended here. And this shape is obviously 3, 7. Make this example even more obvious, more informative. I am declaring, I don't know what this is, 1, 2, 3, 4, 5, 6, 7, 3 cross, another 3 cross 7. Wow. So I'm declaring another 3 cross 7 array here, and I want to append this row wise. So right now this is 3 cross 7. This is also 3 cross 7. To append this to this row wise, use np.append, and then the input array is np array. The new array is this one, new array. Choose axis equal to 0. So this will go append as the new row here. This will go append as new row here, and so on. As you can see, these things have been appended to these. What is the shape of this? Obviously 3 cross 7, 3 cross 7. So now it has to be 6 cross 7. Okay. So this reshape method is very important. It helps you to maintain the dimensions when you are doing inter-array operations. Okay. And I've shown you how the append method also works with axis. So let's try some couple of quizzes here. Okay. And these are just, kind of try and experiment and get it done. Any shape and reshape may different. Shape is an attribute, Parul. Reshape is a method. Shape is an attribute. So if you have an array called x dot shape is a tuple which is already stored. When you declare an array and save it in x, variable x, its size, dimension, shape, these are all attributes. These are all characteristics. Okay, these are all static values. Static values. So when you do x dot shape, you're just calling the shape. It's not a function. It's not a routine. It's not doing anything. It's only telling you the shape. Reshape is a method. Okay, reshape is a method. It changes the structure of an array into another shape. It's a method. Okay, great. So let's try one quiz here. Consider this array shown here, transform it to this array. Okay, anyone else was able to crack this one? Let me also query GPT and see why are we facing this issue. 1 second. Yeah, I'm getting similar what you got. So I'm just going to tell GPT your code is, I'll say your code is giving me 5, -7 in the first row and -2, 3 in the second row. And this is not matching with your output. This is not matching with your output. So if you do that, it will give you something. Okay. So let me, let me just disclose, that method here. So if I just do result dot transpose, now if you see, I'm getting 5 -2 here and 7, 3 here. Okay. Yeah, transpose. And I believe there's a shortcut in NumPy for this, capital T or something. Yeah, see, instead of dot transpose bracket, you can directly use dot T. For 2 dimension, this should work. In 3 dimension, transpose will do something else. We will get to that. But transpose you can think of as nothing but interchanging the dimensions. That's all. In 2 dimension, there is a shortcut dot capital T, which is, by the way, a reference to high school mathematics. I hope everyone gets the reference to high school mathematics, right? In high school maths, we say A and then capital T. That's what, the shortcut is here. Okay, so Python developers have, programmed that reference into the code. The actual method is called transpose. Okay, great. So GPT, I hope you're getting it now. It doesn't have all the answers. Okay, GPT is not, it won't give you it doesn't know what you're trying to ask. So there's a lot of conversation you need to have, and as I said, use it as a reference. Okay, don't use it as a, last time also I told you, it's not going to give you all the answers you seek. You have to use it to learn. Sometimes it will fail, sometimes it's good enough, gives you some code, but you need to debug it, you need to look more. Anyway, so this is interesting. What does it say? Consider the array shown below. NP arrays, whatever. So let me just print it and see what this is. Obviously 2 by 3, right? This thing is obviously 2 by 3. Transform this to -4, 2, 1, 3, -1, 7, 4. Okay, this should be pretty obvious, right, guys? What's happening here? So -4 is -5, 4 is already here. We are appending 2, 1. 3, -1 is the second row here. We are appending 7, 4. 6, -3 is here. We are appending 5, -5. This much is obvious. Okay, we basically need to have new array 1, let's say, equal to np dot array, and since this shape is 2, 2, these 2, 1, 7, 4, 5, -5 also I need in shape 2, 2. So new array 1 will be and you know what, let me just create a new cell so that we understand. So new array 1 should be what? NP array double list, because we need 2 by 2. What are the elements? 2, 1, 7, 4, then 5, -5. Oh no, this is string 5, -5. Now if you print new array 1, see, it is a 2 by 2. So this -5, 4, 2, 1 should be the first row. 3, -1, 7, 4 should be the second row. 6, -3, 5, whatever, this should be third row. This much is easy. What I should do? I should do np dot append np array new array 1. Which axis we are appending? Like this. So column axis equal to 1. -4, -5, 4 to 1, 3, -1, 7, 4, whatever. We got these. And then we have another row. So next what I need to do? I need to by the way, let us store this in a new array or whatever, right? Then I'll print it. So next I need a single row, but remember, we cannot use a one-dimensional array. We need to reshape this to 2-dimension. Okay, one way to do that, directly use double bracket, correct? So one way to do that is new array 2 equal to, I will take this list from here, I'll just copy it. Okay. One way to do that is use double bracket. Okay, and that should ideally give you, as you can see, and if I just do shape and check, oh, it's a list. I forgot to, yeah, np dot array, yeah. So shape is 1, 4. Okay, this is what we need. So one way to do is declare here itself. The other way to do is reshape, correct? So the other way, if I redeclare this, but this time I will not use double brackets. This time I will use single brackets, suppose. Okay. So now if I do new array dot shape, it is 4 elements, but only one dimension. And if you print it, you will get only one list bracket. If you try to append here, it will fail. So what you can do is new array 2 dot reshape, and the shape that you want is 1, 4. Okay. So now let's print new array 2. Now it has double brackets. Now if you do dot shape, you will get 1 row, 4 columns. So now it will go as a new row here, and there are 4 columns for it to match, right? And that's what the question is asking. -3, -5, 4, 8 should be the 4th row. Okay. So after this, all I need to do is np dot append. What am I appending? This one, which is new array. And sorry, that's the input array. And what am I appending? I'm appending this array. So new array 2. Which axis I'm appending? I'm appending as a row. So axis equal to 0. This produces. So we went from this to this using a combination of append, reshape, and things like that. Okay. There are a few questions. One question here for homework. Similar methodology. You can use a combination of transpose, reshape, things like that. Use everything that you have learned to go from this array to this array. All right. Okay. Great. So deleting. Now we saw deleting in 1D. Okay. Let's quickly see deleting in 2D. So suppose I have this array 4.7, 1.4 minus 4.6. I have 3 rows here. All right. What's going to happen if I do np.delete? And I hope we remember the arguments. Okay. So ARR, that's the array, and the object is the index that you want to delete. In fact, you can check the documentation. This indicates the indices of the subarrays. So this is the index. What will happen if I do np delete of this array, and I'll just put index as 0? What happened? Are we able to see what happened? So what happened was these elements were retained. You deleted the first element 4.7, but the rest of it collapsed. So what's happening really is when you apply this, without talking about axis and shape and things like that, it's collapsing this into 1D. And remember, when you delete one by one elements, obviously you cannot maintain the same shape. Not possible. So if you delete this one element 4.7, it's missing now. So there's a gap. Okay, and NumPy arrays do not allow that gap. It has to be a fixed number of rows and columns and other dimensions. So 4.7 has been deleted, but the rest of it is collapsed. Again, this is not an in place operation. Okay, this is temporary outputs. Now suppose I say I specify axis equal to 0. Here I did not specify axis. Suppose I say, okay, take this array, delete 0th element, whatever it is, and axis equal to 0. Now if you notice, it has deleted the 0th row, which means the first row in Python language. So this index with this axis specification means what? Axis 0 means axis equal to 0 means the 0th dimension, which means the first object in the shape. What is the first object in the shape? It's the number of rows. So axis equal to 0 means row wise operation. In row wise operation, what is the 0th element? It is the first row. So when you delete using NP array, the first element in axis 0, that is actually the first row, which is what got deleted here. Okay. So now if you, these are obviously temporary print outputs. Original object is not changed. If you want to change, assign it. If you assign it, you will delete the row from the original object. Now I said you can, give multiple indices, right, for deleting. So right now my np underscore array object is this thing here, which is 2-dimensional with 2 rows and 3 columns. Sorry. What does 0, 1 mean in axis equal to 0? Again, axis equal to 0 means row wise. What is the 0th item row wise? It is the 0th row. 2.6 minus 1.2, this whole row. And what does 1 refer to? 1 refers to the second row. So now if I delete 0th row and first row, which means first and second row in axis 0, right, which is y rows, then what should be the output? Output is null. Done. You have deleted these 2 rows. So now your output array is null. But notice that interestingly enough, your blank array still retains the shape. So funny, right? NumPy arrays. There's nothing in this array, but this array has a shape. 0 rows and 3 columns. Okay, that's how important this shape attribute is in NumPy, and that's so important. It becomes, in future in pandas and things like that. Okay, in data analysis, the shape is still maintained, even the data type. Anyway, so let's redefine our array. Okay, we've deleted all our rows, so let's redefine. Now, how do you delete rows? I think, how do you delete columns? Pretty obvious at this point, right? np.delete input array, choose the item number. In Python, it is 0, 1, 2, whatever. So item number 1 in the first axis, which means second axis, by the way. So columns. What is item number 1 in the column wise? It is the second column. So when I say np array axis equal to 1, I am talking about this column here, this column here, this column here. The 0th column is this one, first column is this one, second column is this one. So when I say delete np array item number 1 in the column axis, that is the middle column here. So this column should disappear. 1.4 minus 1.2, whatever, should disappear. It has disappeared. It has been deleted. Okay. And similarly, you want to delete everything, you can go ahead and delete everything. Okay. Notice that right now the shape is 3, 0. Okay. So here 0, 3. Here you started deleting column wise, so it is maintaining number of rows. Here you're deleting row wise, it's maintaining number of columns. Very interesting. Right? So what you've learned here is that if you delete randomly, element wise, then it will collapse into 1D array. But if you correctly delete axis wise, it will retain the original shape. Okay. And I mean, it's a very obvious question here, which is homework, but I think the answer is very obvious. Can you delete individual elements from arrays? Yes, you can, but what happens if you delete individual arrays? It collapses into 1D. You will lose all the data structure information. You will lose all that information. Right? Okay. Empty. Yeah, it collapsed. Correct. Great. So deleting is fairly simple, and we won't go too much into it because, as I said, in your data science journey, you may use delete here and there, but mostly we will be using operations and things like that. Let's see replacing elements, right? Now, I hope by this point we are understanding that arrays are very, very different from lists and things like that. Okay, this is where your data science is really starting. Okay, this is the, you can say, the ground on which you're taking off, right? You understand all of this mathematical structure, and that's how everything on top is built. Okay, up to list strings and all of those other things, that's basic programming. It doesn't care so much about mathematical analysis. Of course, programming is mathematics, I'm not saying that, but it doesn't really care about things like matrices, vectors, transformation, transpose. These are all data techniques, data science techniques, right? So up to lists and all those other things you studied, basic programming. From here on, which is why this is called Python for data science, right? From here on, we have to start thinking of our data as structured. Okay, number of rows, number of columns, what's the data type, so on and so forth. Anyway, so and why am I saying all this? Because now I think all of this should be obvious. So if I say NP array 0, what does this mean for a two-dimensional array? It means the first row, 4.7, 1.4 minus 4.6, correct? So now if I replace with this list, what should happen? The first row will be replaced with the new replacement. So easy, right? When you start understanding, okay, what exactly the indexing is accessing? Is it accessing a row? Is it accessing a column? Is it accessing a section of that? When you start understanding what it is accessing, then it becomes really easy. By the way, obviously you can index like this and replace. What is this, by the way? What is this? This is all rows 0th column, right? All rows 0th column, which means what? Minus 0.5, 2.6, 6.6. Okay, now I can replace that set of 3 numbers with new set of 3 numbers. So minus 0.5, 2.6, 6.6. This has been replaced with these 3. 1.5 minus 2.4, 5.2. Notice that this is list. Still NumPy array is able to understand. As long as you match the one-dimensional objects correctly, it will do this. Okay. When you do two-dimensional, you may want to do arrays. So I think, for example, here you get an error. Why you're getting error? What is this? First of all, what is NP array? All rows and from first column, which means what? I want all the rows, but I want from column number 1, which means this one. So I need 2.5, 1.7 minus 1.2, whatever, minus 3.2, 4.9, right? So if you see, this is what I've extracted. Obviously, you cannot replace this with 3 by 3, right? You have to replace this only by 2 by 2, right? So here I have 3 rows. So if you just take this, right, and suppose I just say np dot array and print the list. How can I replace these with this? The shape is not matching. Very simple answer, shape is not matching. And when shape is not matching, what is the first thing we try? We try to reshape. Okay. So if I just take this element here, right, the thing I'm trying to replace, which has 6 elements. Right now it has 2 rows and 3 columns. Suppose I reshape to 3, 2. Now I'll get 3 rows and 2 columns. This I can replace on this, no problem. Shape is matching, I can replace. So if you do this, it is able to replace that. Okay. So the one small problem you can see here, right? I think there's one small problem which you can observe. We expected these things to be replaced here, but something went wrong, correct? So if you see NP array, by the way, I have only selected from first column, okay, which means these elements, right? So this 0.6, 1.5, I expected to be here, 0.6, 1.5, and then 4.3, 0.8 that I've expected to be here, right? Which is that's done here, and minus 5.4, minus 4.3, I've expected it to be here, which it has done. Now, if you wanted to actually, if your intention was something else, the most easiest interpretation of something like this will be what? This is a column. So in my original NumPy array, right, I have 3 columns, right? I want this to come here in 0.6, 4.3, minus 5.4, and I want this 0.8, minus 5.4, minus 4.3 to come here. Reshape is not enough. Obviously, reshape is not enough. And we have seen an example of this before. The best way to do that is to reshape and then transpose, or transpose and reshape. Both will give you same result. So if I just take this one and reshape and transpose, this 0.6, 1.5, 4.3 will now appear as a column. This 0.2, minus 5.3, 5.4, minus 4.3 will appear as the second column. This you are replacing on the second 2 column of the original NumPy array. So this one, right? So my original actually had other value, 2.5, 1.7, whatever, right? So this column and this column we want to replace with this column 0.6, 1.5, 4.3, and then this column 0.8, minus 5.4, 4.3. So combination of transpose and reshape is what would replace those 2 columns with the intention that I had, which is I want this to be a new column, I want this to be a new column. So if you do all of that, then you will get this 3 numbers in this column and these 3 numbers in this column. Again, the moral of the story is that as long as shapes match, you will be able to add, delete, replace, and things like that. Okay, so reshape method is used for that. But if you want to correctly place elements in the right place, then you should see what's going on. Okay, so this transpose gave me these 3 values in the column. Otherwise, if you use as NumPy array, we know that this is going to first row. We know that, right? We have seen this in our previous examples. If I just do NumPy array list 1, list 2, then list 1 will be row, list 2 will be row. And now if you reshape this thinking, okay, I want column, and I have 6 elements, so I can just reshape 3, 2. What's going to happen? The elements get split up. So if you wanted this as a column, that's not happening here. Why? Because your reshape 3, 2, what did it do? It took 2 elements from here, put it in the first row. It took 4.3, 0.8 from these 2 and put it here, right? Which makes no sense because this is in a different vector and this is in a different vector. But it has taken these 2 and put it here. And then these 2 is coming here. Now you can replace. Now you can obviously replace the second 2 column, right? Everything except the first column. You can replace this chunk here, no problem. But is that the intention? No. So then you may want to use transpose to, by the way, directly you can just build it. So how to directly build it? That's obvious, right? You just take this list of lists and convert to array. That's all. You just do this np.array and give list of 3 lists. No problem. But this only works for very small number of items. When you're working with immense amount of data, we need to use methods like transpose, reshape, and things like that. So yeah, this is what I've written here. Another way to achieve this would be to actually define it in the actual shape that you want when you start. Okay, so that's one way to do it. So if you do all that, it works. Okay, so I'm going to take a pause here, and probably we will take up this at another time. What do we have remaining here? We have 3-dimensional, and then I think we have operations on arrays. Okay, so just a quick survey of opinions. We obviously need one more session to go with the rest of the content, rest of the topics. Is everyone okay with a session tomorrow? Please let me know in the chat. Is it okay with everyone? I'm going to need way more yeses than that. I have 26, around 30 learners. Come on, guys. Okay. Okay, fine. So, fine. Mostly I'll get a session scheduled for tomorrow evening. Let me just see what is left. We have. Okay, 1 second. I'm just checking things. Sorry. So we have a 3-dimensional replacement. We have vector operations, matrix operations, things like that. We have, okay, all of this is mathematics. If you are learning to code, you probably want to master the tech world. Join our job-linked data science and AI advanced bootcamp program at upGrad and gain the skills employers are looking for with a practical, industry-focused curriculum and hands-on projects. You will learn from seasoned experts and apply your knowledge to real-world problems. To start your data science journey today, click the link in the description box below. So we'll be continuing where we left off yesterday. But to do that, I usually, find it easier to run the previous cells because we've been using the same variable names. And mainly because this is a workbook for learning purposes, right? If you were doing actual programming, then you would be careful in terms of variable names, and you wouldn't overwrite the same variable again and again and things like that. But since we are using this for learning purposes, we are using the same variable name almost everywhere in the code. So it's probably better to run the previous cells, and then continue where we left off. So that's what I'm going to do. And I request everyone to do the same. Those using Colab, please upload the image file and start running the cells. Those using Jupyter, you can directly run. Okay. And as I run through the cells, we'll just quickly summarize the things that we saw yesterday. Okay. Please let me know once everything is set up, then we can continue. Okay, and in the meantime, I'll start running my cells and maybe giving some commentary in terms of recall. So we are discussing NumPy, numerical Python, which is the fundamental package, the most basic and most reliable and most universal package for mathematical computing in Python. So we import NumPy typically as NP. Then we discussed things like, what is a NumPy array? What kinds of elements can you put inside NumPy array? So we saw, for example, arrays from lists. We saw that each array will have a data type depending on the kinds of elements that you put inside. We also discussed that, tuples and sets, it doesn't make too much sense to, use as inputs for arrays. Sets because it's not ordered, tuples because you can typically do the same thing with lists, right? And mixed arrays are also usually not used that much. So this is something, this mixed array business is something that we'll see in tomorrow's session when we do pandas, right? How do you handle this different data type thing in the same list? How do you handle it is something we'll see in pandas tomorrow. Okay. Then we spoke about multidimensional arrays, and I should say at this point that I think we all understand that why should I separately call it multidimensional array, right? All NumPy arrays are multidimensional arrays. That's what we understood yesterday, right? And we saw that the method used to create these arrays is called numpy.array, and the class, the array class, is called nd array, numpy.nd array, n-dimensional array. Then we saw 2D arrays. We saw some examples of 2D, 3D. Then we went into attributes of arrays like ndim, there's number of dimensions, and the most important attribute which we saw yesterday was the shape attribute. And we also how important the shape attribute is if you want to you know work on NumPy arrays. Then we saw how to access elements from arrays. So typically it's the same access method as lists, which is integer indexing, right? So you can do that for 1D, and for 2D it was a little bit more complicated than that, right? So we saw, okay, the first element in the tuple for accessing is the position on the 0th axis, which is the row. Then the second will be the position on the first axis, which is the column. So for 2D, you're just selecting row number, column number, and whatever intersection is there, that element will be extracted. Similarly, for 3 dimension, you will have 3 numbers in the tuple that you use for extracting, right? One second. There's something wrong with my mouse. Give me a second. Yeah, okay, better. Right. So yeah, accessing methods is something that we saw. Shape is something that we saw. Reshape is something that we saw. So reshape we encountered when we were trying to replace elements in the array and do operations between arrays and things like that, right? Appending arrays, appending a row, appending a new column, those kinds of things. We also saw simple Boolean indexing, logical conditions like greater than 2, less than 5, and how you can access elements using logical conditions. Okay. So yeah, this is what we saw in terms of adding elements to arrays, removing elements to arrays. We saw that 1D arrays is pretty simple, right? One-dimensional arrays is very simple, but when you come to 2-dimensional and 3-dimension and more dimensions, then you need to be careful. What is the shape of the item or the object that you're trying to append, and what is the shape of the actual base array on which you are trying to append the new object, right? So in that, we saw that the shape plays a very big role in getting the right output, and we also used methods such as transpose to flip the dimensions of the array, right? So I think mostly this is where we left off yesterday. I think we completed up to 2D. Yeah, so we were here where we deleted one element from 2D, it collapsed to one-dimensional array. Then if you select the axis, then you can the number that you're using here is actually the index of the item along that axis. So for example, in this code here, the original object from where you want to delete is npr, which is this object here, and I put axis equal to 0. So now it is checking the rows, and in the rows, what is the 0th row? It is this one, the first one, right? So then it deletes that. Correct. So these are the things that we saw. Let me see. Oh no. Okay. These are the things that we saw. Let me just rerun these. Yeah. Don't run the cells twice. Okay. Some of these operations are in place, so that may mess up some of the values. Regardless, let's come up to this point. Yeah, we did this. We reshaped, and then we saw column appending and things like that. Yeah. So this is where we are continuing, right? Okay. So has everyone set up their environment and run the code up to that point? Please note that run all will not work because there are some errors in there, intentional errors, right? But as I said, it's for learning purposes. So, are we all at this stage now? I hope we all opened our environment, set it up, and run till this stage. And by the way, even after this, if your variables don't have values, just go back to where you loaded that variable. So what is img? Img is nothing but the array that you get when you load that sun image, right? So just search for that code and put it here. All right, but hopefully we shouldn't be facing that kind of issue. Hopefully everybody has run all the cells up to this one, right? Up to this is where we stopped. There is an easy way to do that. So what you do is you introduce an error on purpose, like where you want to execute, right? Introduce an error on purpose. So what I can do is I can just go select any error. For example, this is an error, right? So I can go to the location in my code where I want to run everything till that point. So for example, I want to run till this point. So this is going to give error, right? So I'm intentionally introducing this error here, and then I just scroll up. Wherever there's an error, I can comment out the code. For Jupyter, it is control and // I think same for Colab. Okay. So for example, right now this is code. I can just comment. Now when you run it, it will not run. So it won't give error. And then it will continue to run because it did not run this code, right? So I'm just going to go and see in my code where are my errors, right? And it's a foolproof way, by the way, right? So here there's an error. I'll just comment. There's another error here. Comment. Right? I'll just go through the code and see if there are any other errors here. Because errors in Jupyter don't allow you to continuously run the code. It will not go to the next cell. So let me just find out where are my other errors. Accessing, what is this? Attributes will not have errors. Yeah, here's an error. Comment that. And somewhere here there should be some errors. Yeah, it's one. This is an error, obviously. Accessing from set, that's an error. And here again, it's a blank array, I think. Yeah, not a blank array, it's a dimensionless array. Yeah, okay. So I commented out every cell that gives me an error up to the point that I want to run, which is somewhere here, right? Here. Yeah. So up to this point here. So we were like yesterday, we stopped at this array here where we were trying to get this row into column format and then append it to the array. Okay. So this is the point. So I've introduced an error on purpose here, and every previous error I've commented. Now I can just restart and run all. Ideally, it should run everything without any problem till the position where I have intentionally given an error. Let's see if that worked. Yeah. So it has run everything smoothly till the point where I gave it an error. Now I can just comment this out. So we were discussing addition, deletion, and changing values in NumPy arrays. And we saw that whenever we do any of these kinds of activities in NumPy arrays, the shape may or may not change. So if you want to preserve the shape of your array, then you should be careful with your operations, right? That is what we saw. Now, for example, take this array. And by the way, at this point, we should be comfortable enough to read an array in list form. Okay, so obviously when I print this array here, np.array 1 2 3 minus 2 0 5, when I print it, I will get 3 rows and 2 columns. But before printing itself, we should know. I think we should be at that stage. Okay, which is, by the way, the whole point of these rigorous exercises is to build familiarity with the programming language and tools and objects, right? So by just looking at this, I know it's going to be row number 1 is 1, 2, row number 2 is 3, minus 2, row number 3 is 0, 5, correct? So as you can see, right, 1, 2, 3 minus 2, 0, 5. Now I've printed np array, so you can only see the list notation because I've used the print command, and I've also printed the shape of this array. So this array has a shape 3, 2. Okay, 3 rows, 2 columns. And transpose, what is the method transpose? What does it do? So obviously we saw that it interchanges the two dimensions. So your rows become columns and column become row. So 1, 3, 0, this column became the row here. 2 minus 2, 5, this column became the second row. And notice that the dimensions actually have changed, interchanged. So here it is 3, 2, here it is 2, 3. Okay. The interesting thing about reshape is that you can reshape it into other dimension distribution also. For example, 2 into 3 equal to 6. So I can actually reshape this into 1 comma 6, right? So if you take the same array, which is this one, 1302 minus 2, 5, that's why it's the transpose here, right? The same array, if I take it, and if I do dot reshape 1 comma 6, then what happens? If you see, this 2 minus 2 5 has appended here. So here you have 1302 minus 2 5. Same way, if you do for this array, if you do np dot array 123205 without the transpose, the shape is 3 comma 2. So if you take this and reshape, for example, if you take this one and reshape it with 1 comma 6, then 1 2 3 minus 2 0 5. That is what you should get here. So as you can see, 1 2 3 minus 2 0 5. Basically, the point I'm trying to make here is, don't expect NumPy to know what is in your mind, basically, right? It has a certain set of rules that it is following, and typically it follows integer indexing rules. Okay, so here this is the first row, this is second row. Now you are asking it to convert to 1 row and 6 column. What is the most obvious thing to do in this case? Most obvious thing is take second row and put it after the first row, which is what was done. Similarly, if you give this format and then say reshape it to 1 comma 6, most obvious thing here is take 3 comma minus 2, put it in the top, take 0 comma 5, put it next to that. So NumPy has a very strict way of doing these operations, and you need to understand what is happening due to these commands. Okay, that's essentially the point that I'm trying to make here. So now let's quickly have a look at the three-dimensional array. So this is the image, which shape is I think 25 32 3. So it has 3 dimensions, right? One dimension being rows, number of rows, one dimension being number of columns, and the other one being number of channels. So for example, in fact, I don't need this. Yeah, I'm just deleting those 2 cells. If you want, you can comment it, guys. I don't need those. I'm just going to take this and put it here. Yeah, image. Yeah. So those, by the way, delete shortcut is escape and then press D twice. Okay, escape D. Okay. Let me just write it here. If you want to delete a cell, it is escape D. Okay, escape, press D. Okay. Learn Jupyter shortcuts also as you go through this, and same way Colab also has similar shortcuts. This will be very useful. Anyway, so I did not want that temp image at all because my image shape is already 25 32 3. I think that was for 32 32 3, so forget that. So anyway, here my image shape is 25 32 3. And what am I doing here? Notice this. Okay, now I'm doing np.transpose. Okay, that is different from array.transpose. Now here, if you see, this is np.array.transpose. This transpose method is applied to the object. Okay, the transpose method is part of the object. Okay, the array object has a method, inbuilt method. It's associated with the object. This np.transpose is a global function. It is NumPy transpose function. It is not associated with any object. A NumPy.transpose. Okay, it's a function. In that function, I'm passing my input array, which is img, and I'm also passing the new ordering of the dimensions. Okay, now let's see what this means. So right now my image shape is 25 32 3. Okay, in this, what are the positions of these numbers? How do you do that? img.shape 0, that gives me 25. Okay, img.shape 1, that gives me 32. Simple tuple, right? This is nothing but a simple tuple. Then you have img.shape 2. This thing gives me 3. Okay, obvious. 25 32 3. 0 1 2. This exact 0 1 2, what order do you want to change? That is what I'm passing it here. So 0 1 2, I now want 0 to go to second position, 1 to come in 0th position, so on and so forth, right? So I'm giving the new ordering. So this function allows you to and by the way, it of course it produces an array. Okay, it gives you an output array. what is really interesting is, and also this is, not an in-place method. So if you want to retain the new array, this new array, you need to assign it somewhere. So I'll assign it to this new variable, new temp image, right? This one. And if you see the shape, notice that it is 32, 25, 3. Go back here and see. This shape is 25, 32, 3. 0 was 25, 1 was 32, 2 was 3. And you told I want 102. So now 32 will come in this 0th position because you put 1 here, correct? So this 32 will come to this position. Then the next one is 0. So 25 will come in this position and 2 remains the same. 3 is here itself. So if you see here, now the shape is 32, 25, 3. So for more than 2 dimensions, because it's not obvious, right? For up till 2 dimensions, what you have is a matrix, right? And transpose of matrix is obvious. You have only 2 dimensions. So transpose means it will change the rows and the columns. Sorry. But when you're dealing with 3-dimensional and higher dimensional arrays, you have the choice to specify what is the order of the dimensions that you want. So if you have 3 dimensions, 0, 1 and 2, if you do just dot transpose, it will take the default values, which you can check, check the documentation and see what is the default values. There must be some kind of default, but you can specify the order. Okay. So for 3 dimension and above, transpose works the same way. Transpose just means interchange of dimension, but since you have more dimension, you need to specify. Okay. So these are very interesting methods, reshape and transpose, especially the combination of reshape transpose. I have used multiple times when I was working with NumPy Arrays, when I typically work with slightly more advanced ML models. These two are important on their own, but combinations of these two really help out. Okay. Suppose let's go to quiz 10. Consider array shown below. This is NP array 100, 200, 300, 400, 500, 600. Okay. So it has what? First row, second row, third row, and it has 3 columns. So obviously this is 3 by 3, 2-dimensional. Question is, what does NP array dot reshape -1 do? Okay. So this is a very useful method, this reshape -1. Everybody please try it out. And can you put in the chat, like what is your output? Obviously, I mean, I'm not going to tell you guys to run this. In this case, nothing will happen in the quiz number 11 because already you have 1D. Okay, already you have 1D, so it's going to remain 1D. Please attempt quiz number 12. Can everyone attempt quiz number 12 and tell me what's happening to the output? Quiz number 11, as I said, it's pretty simple. You can run it on your end, no problem. Run it if you want. The original array is also 1D and shortcut method is converting 1D to 1D, so nothing will happen. You will get the same array. Quiz number 12 should be a little interesting. np.array reshape -1, this. What is the output? Try quiz number 13. Again, there is an array here which looks like a 2D array, and so we can investigate the output of this as well as this. Please try quiz number 13 and see what output you're getting. What are we getting for quiz number 13? So you can just copy this from the question, by the way. You don't need to type the array. I hope nobody is typing all this. You can just copy this from the question and put it in the cell. So I've copied, put it here. And first I'm executing this command. Again, I'm copying this code here and executing this command. So what do you think -1, what's going to happen? You're going to get single array collapsed into 1D. Excellent. Correct. Okay, let me run that. So here it is collapsing to 1D. This is obvious. What about -1, 1? I think we have some answer here. It's changing into 2D. So what happened though? It's changing into 2D, but what was the original shape? The original shape here is 2 cross 3. Now the shape is 6 cross 1, isn't it? So these are your shortcuts for creating column vectors and row vectors. So if you want this to convert into row vector, then just try this. Okay, make one more cell here. Oh, by the way, the shortcut for cell is escape A. Okay, in Jupyter, escape A. I think same shortcut for Colab also. So just press escape and A, you will get a cell. Okay. So try doing the same command, but this time interchange -1 and 1. Okay, interchange this. Do np.array reshape 1 minus 1 and see the output. Page link. Just wanted to share some very interesting commands that we might use a few times in backend when we are programming things into the back, right? Wherever we want to collapse into column vector, wherever we want to collapse into row vector. So there are some of these very interesting shortcuts from reshape which are available. Okay, couple of homework questions. I will again leave it for you guys to do, and we will move on with the, you can say, conceptual second half of the NumPy topic. So till now we have spent our time familiarizing ourselves with the NumPy array class and very important attributes and methods such as shape, size, how to add things, how to subtract things. Those are the things we focused. Now we will go into the second half of NumPy arrays or NumPy session or NumPy topic, call it what you want. So the second half is mathematical operations. Okay. The page which we are doing now. For example, here I have a vector, -1, 3, 4, -6, and then I have one more 0, -5, -2, 10, and I'll print both. So this is my first array. This is my second array. Now, just to make it very obvious, right? If I just add the two lists instead of the arrays, what is going to happen? That's an output. I'm very sorry. That's an output. I can't add outputs without commas. I forgot the commas, obviously. So let me just put the commas. So right now these are lists. So you all remember lists, right? If you use plus, what's going to happen is it's just going to append this list to this list. You don't have vector operations in lists. You don't have any particularly focused mathematical operations feature in lists. Okay, that's the advantage or the reason why NumPy arrays came into existence. That's why people built the NumPy library. So now these things are actually arrays, right? So NP array first array and NP array second array. So vector number 1, vector number 2. So suppose I add this vector number 1 plus vector number 2, and I'm printing the addition. So if I just do v1 plus v2, what do you expect? The components should be adding, correct? If we remember vector addition from school, then we expect that -1 plus 0 should be -1, 3 minus 5 is -2, 4 minus 2 is 2, so on. So I just need to do v1 plus v2. Let us see. As you can see, it gives me the exact vector answer. -1 plus 0 is -1, 3 minus 5 is -2, 4 minus 2 is 2. Okay. Similarly, you can do difference also. Right, -1 minus 0 should give me -1, 3 minus -5 is 8, and then 4 minus -2 is 6, and then -6 minus 10 is 16. So v1 minus v2, -1, 8, 6, -16. Okay. So clearly, the whole reason of working with NumPy arrays is for performing mathematical and vector operations, right? And it does it very seamlessly, very fast, very clean, right? Now let me take this vector, the first vector, -1, 3, 4, -6. Okay. Suppose I just add 10. Now we have seen, okay, what happens when you do v1 plus v2. So v2 is array whose length is same as v1, right? So you can experiment later what happens if you use different length, but maybe you already have some hint about that, right? But here I'm adding this with this, right? These are same length arrays. So then component wise addition is happening. Same way component wise subtraction is happening. What if I just add plus 10? So v1 is this 4 element array here. What's going to happen if I add 10? Interestingly enough, this 10 is added to each element. Okay. This is called broadcasting, right? The value, this operation called plus 10 is broadcast to all the elements here. So minus 1 plus 10 is 9, 3 plus 10 is 13, 4 plus 10 is 14, minus 6 plus 10 is 4. Right? So essentially it's creating a same shape array in the backend. So when you do v1 plus 10, the plus 10 operator on the array is creating 10, 10, 10, 10 and then adding it to the array. Now suppose I have different shape. So here we are talking about 1 dimension. Let's go to 2 dimension. So I am printing my v1 array here, and it's okay to call it matrix, but typically in data science we just call it 2-dimensional array. Okay, so it's almost as if the word matrix is some kind of old-fashioned term, right? I don't know, but whatever. So we have a 2D array here, and obviously first row is 5 minus 4, second row is minus 3 2. Again I have another 2D array here, 3 minus 8 minus 6 0. Okay, now if I add these two, what is the expectation? I think everyone knows, right? What's the expectation? 5 plus 3 should give me 8, minus 4 minus 8 should give me minus 12, minus 3 minus 6 should give me minus 9, and 2 and 0 should add and give me 2. 8 minus 12 minus 9, 2. Okay, clean, perfect mathematical operations, which is exactly why this thing is called numerical Python. Okay, NumPy. Similarly, you can do difference between the 2D arrays. You will get component-wise subtraction, and so on. What do you think will happen if I now broadcast plus 8 to this array? So v1 is 2-dimensional, right? What will happen if I broadcast plus 8 to this array? Well, it is going to make an array of 8, 8, 8, 8, 8 in the shape of the v1 array, and then it's going to add. So 5 plus 8 is 13, minus 4 plus 8 is 4, minus 3 plus 8 is 5, 2 plus 8 is 9. So I think you're starting to see where this is going. Why all these things need to be perfectly reliably sorted out at the NumPy library stage. Because after this, when you do data science, data analysis, data manipulation using the other tools and other packages, those tools and packages are expecting such behavior. Correct? So think of any use case, right? Suppose I have a group of data, and suppose there was mistake in measurement. Okay, suppose dollar was confused with rupees, and now I have to convert all of this money data back to dollar. So I need an ability to broadcast numerical operation on like millions of data. I am showing you example with 4 numbers. Same thing can be done with millions of numbers. Yes, right? So that's exactly where this is going now, right? We understand all of these operations, and then when we use pandas and other tools and techniques for data science, all those are expecting NumPy behavior at the backend. Okay, which is why those things are even possible in the first place. If I did not have such strict mathematical foundation, it wouldn't be possible to make a data analyst life easy. It wouldn't be possible. Okay, so just a little bit of input there. Anyway, now again we can do some more interesting things. So for example, sum array, right? I have this new array here, sum array. And what do you think sum array 0 is? What exactly is this? What is the sum array 0? We all know what this is, right? This is the first row. So I can do 0, or I can do 0 and colon, right? It will give me the first row. Okay. So by the way, why is it giving even if you don't access with a tuple? Because by default it goes to the 0th dimension. So if you actually want the first column, then you have to do colon comma 0. Okay, then you will get 13.5. Okay, so and if you want to retain the shape, I think we all remember how to do that. Oh, sorry, that's yeah. So you do this, and if you want this thing as column, then reshape -1. Yeah, that gives you column. Anyway, so now sum array 0 is actually extracting the first row. Okay. And I'm broadcasting +3 to the first row. So 13 plus 3, 16, 4 plus 3, 7. So what will be output be of the total array? I am only broadcasting to first row. So the first row is replaced with first row plus 3, which means 13 plus 3, 4 plus 3. So now I will get 16, 7, 5, 10. As you can see here, 16, 7, 5, 10. Okay. So the point of this is that you can use various kinds of indexing to achieve what you want. Okay. So for example, here, what is this supposed to be? This is obviously the first column. So right now my sum array is 16, 7, 5, 10. What does this extract? Colon, comma 1. It should obviously extract 7, comma 10. Correct. So now this 7, comma 10, right? This column I'm extracting here, and I am subtracting 5 from the column. So what should I get? 7 minus 5 is what? 2, and 10 minus 5 is 5. So only by manipulating this column, then I can print the full array. And as you can see, 7 minus 5 is 2, 10 minus 5 is 5. The other column is not disturbed. So you can actually identify pieces and sections of your data where you need to do some corrections, where you need to do some processing. Okay, and all of this is based on the indexing. You can also, for example, add column, add vector, do vector addition with the column. So right now, my colon, comma 1, this will extract 2, comma 5, correct? Because as you can see in all of these previous cells, I am overwriting my original array. So right now, sum array is this one, 16, 2, 5, 5. So what is colon, comma 1? It gives me 2 and 5. That 2 and 5, I am adding 3 and 7. So now 2 plus 3 is 5, 5 plus 7 is 12. Now if I print the full array, I will get 16, 5, 5, 12. Yeah. So this is pretty simple, right? Mathematical vector addition and subtraction is position based, and it's very neat and clean, right? As long as you maintain the shape. So now I think it's time to go to image, the 3-dimensional array, right? So here, for example, okay, and so this is obviously very, very big. It is 25, 32, 3. So I am going to work with a smaller section of the image. So suppose I extract the, first 0 and 1. So first 2 rows, first 2 columns, bottom patch. Yeah. So, top patch. Yeah. In images, 0, 0 starts at the top left. Okay. Just to give you visual, what I'm doing is I'm extracting these 4 pixels here, top left. Right. So I'm extracting those using slicing, right? 0, 2, 0, 2. Right. This gives me 2, 2, and I'm taking all the channels. So now you will get, 1, 2, 3, 4 pixels. Okay. And you have 3 channels. So you have red, green, blue, red, green, blue, red, green, blue values you have here, and you have 4 pixels that you extracted. Okay. Notice that the data type here is integer. This will be very interesting right now in a while. Similarly, I'm also going to take the next 4 pixels. Okay, 2 to 4, 2 to 4. So this will give me 2, 3, 2, 3. Right, 4 pixels in a square with the row and column indices 2, 3, and then 2, 3. Okay. So, and all 3 channels I will extract. So now I have the next 4 pixels with all 3 channels. Both these shapes are the same. Okay. Now you can check img1 dot shape equal to img2 dot shape. Right. True. The shapes are the same. I can obviously now add them. So if I add img1 and img2, what's going to happen? 0 plus 11. Just position wise you check. 0 plus 11 has to come, and then 62 plus 83 has to come, 176 plus 204 has to come, so on. Right. So if I just add it, you will notice a very interesting thing. Now 62 plus 83 is 145. No problem. 0 plus 11 is plus 11 is 11. No problem. But 176 plus 204 should give me 124. That doesn't look right. Obviously, 176 plus 204 is 380, right? Why is it giving me 124? The reason is that you're working in integers. Okay, you're working in uint 8, so it only knows values from 0 to 255, and the size of that cycle is 256. So what's happening is 176 plus 204, which is 380. How much more than 256 it is? It is actually 124 more than 256. So it's going in that integer cycle. Okay, that's why you're getting this value. We can change that obviously by specifying the data type. This is where data type, it's of use. right? Similarly, even in the negative ones, you might expect to find negative values, but why are you getting big values? For example, 0 minus 11 should be minus 11. Why is it 245? Again, because it is 256 minus 11. Okay, you're working in base 8 integers. So to avoid that, you can specify the data type. You can say float 32, for example, very common data type. So now every data is float point. So 181 point, 176 point. These are floating point numbers. And this time, for example, let me take slightly bigger section. I'm taking 2 rows and 3 columns and all 3 channels. Okay, so 3 columns for the first row, 3 columns for the second row, and 3 channels. Okay, so I do that for image 1, and I'm also doing it for image 2. And now if you add, you will not run into cyclic integer problems because your data type is now float. So 176 plus 204 is now correctly giving me 380. Same way, 0 minus 11 will correctly give me minus 11. Okay. Again, we can do broadcasting operations like this. So for example, if I just take image 1, which is, what is the shape of this? It is 2 by 3 by 3. Okay, you can check that. 2 by 3 by 3, right? 2 rows, 3 columns. You have these 2 are the row dimension. These 3 are the column dimensions here. 3 here and 3 here for each row, right? And then 3 channels for each combination of row and column. Okay, the way to read this, again, just to iterate, the way to read this, you have 2 rows, which is the first level. Okay, first level is 2 rows. Then within each row you have 3 columns. So within the first row you have 3 columns, within second row you have 3 columns. Within each combination of row and column, so within the first row, first column, you have 3 channel. Within first row, second column, you have 3 channel. Within first row, third column, you have 3 channel. Within second row, first column, you have 3 channel, so on. Okay, so this again, just to reiterate the point that arrays are structured like nested lists. Okay, the only difference between nested list and array is that arrays allow for mathematical operations, lists typically don't. Okay, that's the only major difference. Anyway, so now if I take this section of the image and I broadcast 20, what is going to happen? Obviously it's going to add 20 to all of these. So we've already seen that you can broadcast. Now what have I added? Actually, this is all rows. No, not all rows. So out of image 1, I have taken 1 channel and all the rows and columns. That's what I have done here. Which channel is this? It is the second channel, RGB, green. So it has taken where is it? The second channel, which is green. So it has taken 62, 68, 67, 63, 74, 70. Okay, I hope that accessing is making sense to you guys. All rows, all columns, second channel. So first row, first column, second channel, 62. First row, second column, second channel, 68. Okay, it's taking the second channel from each combination of row and column because that's what I've specified here. So this subset of this, if I add 20, then 62 plus 20, 82, 68 plus 20, 88, 67 plus 20, 87, 63 plus 20, 83, 74 plus 20, 94, 70 plus 20, 90. Okay, so now I can replace this section back here and only these column values will change, which is what I've done here. So if you do that, 022, 195, and only the columns, the values that you changed, you can replace it here. Okay. All right. Yes, Akash, the image will change. I would request you to explore methods for saving image. Matplotlib, I think plt.save or image.save. There is a method. Just Google it or ChatGPT it. There is a method for saving the image, and yes, the image will change. And when you view the image, it will change. In fact, I mean, right now this is a subset, so it won't make sense if I show the image. Maybe you can do the similar operation for the whole image. In fact, we have a quiz coming up on the same, what you mentioned just now. We have a small quiz on that. Okay, great. Right. So let me like solve one of these. Maybe you guys can solve the one after that. Okay. So consider the arrays shown below. I'm just going to take these arrays, put it here. Clearly, I have. What is the shape of this array, guys? Just by looking at it, can we tell the shape? I have 3 rows and 2 columns. This is 3 by 2. Here I have 2 rows and 3 columns. This is 2 by 3. The question is add the 2 arrays to produce the following array. Now, before we even attempt this question, right, what will happen if I just add array 1 and array 2? First of all, let us just get the shapes, right? Array 1 and array 2. Okay, so 3, 2, 2, 3. Now, what will happen if I just add the 2? Sorry. Operands could not be broadcast together with shape 3, 2, 2, 3. Shape mismatch. Obviously, you cannot add. Okay, you cannot add directly. The question says add these two to produce these. Now try to take some hint from the question. See, 1 plus 1 is 2. Okay. This minus 2 plus minus 7 is minus 9. Okay. I have 5 plus 8, which is 13. So obviously some addition is going on here. Right. So to solve this, what you can try is you can print the arrays like this, right? Just to get some visuals. You can print the array. And suppose you do, dot transpose here, right? One method that we've learned is dot transpose. What will happen if I add these two? 1 plus 1 is 2, 3 plus 0 is 3. So I already got my first row. Okay. Minus 2 minus 7 is minus 9. Okay, I got this number. 5 plus 8 is 13. Great, I got this number. Pretty obvious, right? I just need to do array 1 plus array 2 dot transpose. So I just need to do here array 1 plus array 2 transpose, and you get the required array. 2, 3, minus 9, 13, 10, 3. As you can see here, 2, 3, minus 9, 13, 10, 3. Yeah, pretty straightforward, correct? So do this one, right? Do this quiz 16, confirm your result, and then try to do quiz number 17. Okay. So whoever has done quiz 17, you can put your final command in the chat and we will check it out. Okay. Have we all validated quiz number 16? Please tell me in the chat. Quiz number 16, have we done? That one was kind of straightforward. Quiz number 17, I've printed the arrays here, and maybe I'll give a small hint. See, these are my two arrays, right? If you see 1, 3, minus 2, 5, 6, 7, that is the first array. Then 1, minus 7, 0, 8, that is my second array. Question is add to produce this. Okay, 2 minus 4, minus 2, 13, 6, 7. Now, obviously 1 plus 1 is 2. 3 minus 7 is minus 4. So directly adding these two rows will give me this. Similarly, directly adding minus 2, 5 and 0, 8 will give me minus 2, 13. And the third row in the answer, 6, 7 is already there. You don't need to add anything. I hope that is enough hint. Okay, so let me just print the result that we need, then we will check. This is the array that I need. What There's a bracket missing here. This is the result I need from these two. Okay, 1 comma 3 plus 1 comma minus 7. This is correct. 2 minus 4. Okay, minus 2 5 plus 0 8 is minus 2 13. 6 comma 7 is there. Now, how do you add? What is the correct command to add these two arrays to produce this one? That's the question. GPT may or may not help you out. Okay, already we saw that it has some limitations in arithmetic and numbers and things like that. Okay, hint number 2, we have to use indexing. Okay, if you remember, we, for example, this kind of thing, right? We change section of the array and then assign it to that section of the array and then print the original array. Okay, where is this? Here. Anyone able to solve it? So typically I can give around 1-2 minutes and then I will have to demonstrate and continue. Okay. Anyone? Has anyone done it? No. Okay. Guys, then look at the screen. Okay. If you're still trying, it's fine. Right. This is a learning session. So please check the screen. I mean, view the screen. Please stop what you're doing. Look at the screen. Now, the question says use array 1 and use array 2 to produce this array here. I know that 1 comma 3 and 1 comma minus 7, if I add, I will get 2 comma minus 4. No problem. I know minus 2 5 and 0 8, if I add, I will get minus 2 plus 0, which is minus 2, and 5 plus 8 is 13. No problem. The only problem here is this, the third element, 6 comma 7. But that I already have in this array. The only other problem is obviously, as I showed you just a while back, you cannot directly add these two arrays because the shape is not matching. Now, ideally, when the shape is not matching, you may think of reshaping and things like that. But if you reshape here, what will happen? If you reshape here, you will run into position mismatch problems. So that's not necessarily a good idea. You can do it. You can. There are many methods to do it. The easiest method I can think of is to pull out this section and then add it this, right? So how to pull out the section from array 1? I need the first 2 rows and all columns, correct? First 2 rows and all the columns. So one way of doing that is up to 2 comma all columns, right? Array 1 rows up to 2, which means 0 and 1. So you pull out these two, and comma colon, which means all the columns. So this actually pulls out these 2 rows. Okay. Now I know that I can add this with this. They have the same shape. This subsection of the array and this array 2 have the same shape. So if I just do array 1 plus array 2, right? 1 1 gave me 2, minus 7 3 gave me minus 4, 0 and minus 2 gave me minus 2, and 8 and 5 gave me 13. So I got these two. So the only thing I need to do now is I need to substitute this back in the section. So this is the section that you started with. Replace that section with this result. Okay. And then the original array itself would have been updated. Now if you see array 1, this is exactly the output that we need. Okay. I hope it is clear. So you can, now this is one method. What did I do? I basically, what did I do? I indexed this section of the first array. I added the second array back into this section of the first array, and then I printed the first array. That's all. So where is that operation? Here. Not this one, sorry, here. So I have indexed the first array, added the second array to that subsection, and then replaced it to that subsection. So basically, in a sense, I have taken this and overlaid it on this, the first two rows, and I've added. Then I've printed the array. Now, of course, you can try other methods if you want. Okay. Now another. Okay. Now, the array is already printed. Just to give you alternate method, you can try collapsing both arrays into 1D arrays, add them, and then reshaping it to the required shape. Please try it later. Okay. Those who want to try it later. All right. Now we have seen addition. Okay. We can start talking about multiplication. So suppose I have this array, and this is 3 cross 3, right? 0.7 to 1.3 minus 3, 4, 2.5. Notice that here I have integer 2, but it has been converted to float. Okay. You have to maintain data type. Why it got converted to float? Because I have floating numbers, 2.5, 1.6, whatever. So 3 cross 3 array I have declared. Okay. Now what is going to happen if I multiply by the scalar 2? It's going to broadcast into 2 to all my elements. So 0.7 into 2 is 1.4, 2 into 2 is 4, 1.3 into 2 is 2.6, whatever. Notice that again, this is not an in-place operation. It is a temporary output. So many of these things, as I mentioned yesterday also, a lot of these things are temporary outputs. So if you really want to update your array, then you need to assign it back. So this result you can compute here and assign it back to your array. So now your original array will be updated. Okay, now all the elements in this array have been multiplied by 2. You can also do indexing as shown before. If you do, what is this, right? Let's try to read this. Currently this is my array, right? What will NP array colon 2 comma colon give me? This means give me every row up to 2 excluding 2. This is another thing with Python we should remember. Indexing is exclusive. So it will exclude the position number 2. It will give me everything from starting to 2 except 2. So 0 and 1. 0 and 1 means this row, this row. Now in these two rows, I am saying give me all the columns. So 1.4, 4, 2.6, minus 6, 8, 5. Okay. So this section I am saying multiply by 2. Okay. So it pulls out this section and it has multiplied by 2. Okay. You want to reassign it back to the array, you can do that. But obviously you cannot broadcast this into a different shape. Okay. Different shape you cannot broadcast. What shape you can broadcast? You can broadcast into 3 by 2. Because the operation that you're doing here, it is resulting in a, sorry, not 3 by 2, 2 by 3. The operation you're doing here is resulting in a 2 by 3 n-dimensional array. So this you can broadcast back into any 2 by 2 section, by the way. I can change this indexing here to actually index the second 2 rows and it will still replace. But that is obviously not what we intended here. So I will replace it in the same section, which is the first 2 rows. Okay, so 1.46, all of these will be multiplied by 2. This should be as it is. Minus 3.2, 9.8 should be as it is. As you can see, it does the same. Okay. Similarly, you can also do division, right? So division by 5. Now this is my current array. If you divide by 5, what will happen? 10 divided by 5, 16 divided by 5, 2.8 divided by 5. It will divide all the elements by 5. So 16 by 5, 3.2, 10 by 5 is 2, 2.8 by 5 is 0.56, whatever. You want to assign it back, you have to use npr equal to npr by 5. You can assign it back to the original. Section wise also you can do divisions. All rows and from first column up to end. Let's try to read this now. All the rows and then from first column up to end. When I say first column, I mean column number 1. Okay, and in Python column number 1 is this, the second column. Okay, so all the rows starting from column number 1. So this section 1.6, 1.04, 3.2, 2, 0, 1.96. Okay, so what should I get? 1.6 divided by 2 is 0.8, and then this will be 0.52, whatever, 0.8, 0.52. 3 by 2 divided by 2 is 1.6. whatever. Correct. You can assign it back and update your array. Okay. Now this is obviously sort of scalar multiplication, right? Suppose you take something like this. Suppose you take one row. So I am taking from vector 1, I am taking the first row, which is 0.6, 0.8, 0.52, and from vector for vector 2, I am taking the second row, which is minus 2.4, 1.6, 1 point nothing. That's 1. So basically this row I have extracted here and this row I have extracted here. What will happen if I do vector 1 into vector 2? Interestingly enough, it does position wise multiplication. Okay, very interesting stuff. Position wise multiplication. I hope everybody is now remembering something called dot product. Right, this was something that we studied in vectors and vector algebra, those kinds of things. So as you can see, NumPy is bit by bit, step by step, giving you all the stepwise operations for all the mathematical operations that exist out there. It could be anything, area of triangle, it could be finding the resultant force vector, whatever, right? NumPy has all the fundamental steps covered. So here you can see it is doing element wise multiplication. 0.56 into minus 2.4 is here, 0.8 into 1.6 is 1.28, 0.52 into 1 is 0.52. Okay. Of course, again, this is not in place. So if you want to save it in a new vector, then you can save it. All right. Okay. So do you guys, I think we are ready to try a quiz on our own. So please try this one. These two arrays multiply to produce this. And a bracket is missing. Right. So these are my arrays. Array 1 is this. Array 2 is this. Okay, these two should be multiplied to produce this. Feel free to use additional operations if you want, but I think it should be very obvious what's going on here. Okay, quick hint: 3 into 7 is 21, or 3 into minus 7 is minus 21. Minus 21 into 10 is minus 210. So can we give the one line command for this, guys? Okay, anyone who solved it, put your one line command in the answer in the chat. Straightforward, right? No, not straightforward, Akash. You're saying 1 into 1 into 10 is 10. 3 into minus 7 into 10 is minus 210. Minus 2 into 0 into 10 is 0. 5 into 8 into 10 is 400. This is not straightforward. If you're talking about the NumPy not being straightforward, I agree. But the mathematics here is very straightforward. Anyone? What can you do? Array 1, what is the set of operations? What's the simplest set of operations to produce this from these two arrays? And by the way, guys, feel free to raise your doubts. I think as Sonal had raised, if your doubts pertain to the session and the topic, right? And you feel that they are valid, please go ahead and raise. So indexing is obviously the main thing in NumPy and all that. Nobody has the solution yet? Anyone? Okay, maybe I'll solve it and okay. So guys, okay, look, I have array 1 here, which is 3 cross 2, right? 3 rows and 2 columns. And I have array 2 here, which is again 3 cross 2. Okay, both the shape are same. And the question is telling me use these two arrays and produce this array. And if I just take this and print it here, it's again a 3 cross 2 array. Now one pattern I can observe is 1 into 10 is 10, 3 into minus 7 into 10 is minus 210, so on. So what's happening is I can multiply array 1 with array 2. For example, if I multiply, let us see what happens, right? Array 1 star array 2. Notice that I have 1, minus 21, 0, 40, 24, minus 2, 21. I just don't have these additional zeros. That's all, right? I have the exact same array as the question says, except I don't have this factor of 10. So all I need to do is multiply by 10. And as you can see, this simple command, array 1 into array 2 into 10, produces the exact array that is required in the question. This is the simplest set of operations that you can do to go from these two arrays to produce this result. Okay, it's a simple position wise multiplication. And by the way, I showed you position wise multiplication for one dimensional, right? I showed you for 1D. So I showed you this vector 1, which is this one dimensional array here, and vector 2, another one dimensional array. And I showed you multiplication between the two vectors. Obviously, this is not complete dot product or cross product. It is not. It is only doing component wise multiplication. So 0.56 into minus 2.4, right? Position 0. It is matching the two positions, like whichever same position numbers in the two different arrays, and it's multiplying those two and giving the answer. So 0.56 into minus 2.4 came here, 0.8 into 1.6 came here, 0.52 into 1 came here. So when your arrays have the same shape, it's going to produce element wise operation, be it addition, division, subtraction, multiplication. Okay. So in this case, in the quiz, we have two dimensional arrays, but the exact same concept is applied. Exact same technique is executed. If the shape is the same and you multiply the two arrays, it will check the same position in both the arrays and it will perform the operation. So 1 into 1 is 1, 3 into minus 7 is 21, 5 into 8 is 40, minus 2 into 0 is 0, 6 into 4 is 24, 7 into minus 3 is minus 21 again. So array 1 into array 2 produces this 1, minus 21, 40, minus 21, 0, 24. Then I also spoke about broadcasting operations. Broadcasting means apply to all the elements. That was very simple, right? So this result, you just multiply by the number 10, then multiplication by 10 is applied to all the elements of the result. So the intermediate result in this case, that is this, right? 1, minus 21, 0, 40, 24, minus 21. To this result, I can now multiply 10, which will then produce the array asked in the question. Clear? Okay. Okay. So theoretical mathematics may be a different, ball game, right? Maybe that is difficult, but NumPy, as you can see, right? Like, as you can see what I'm doing right now in the session, right? So do you think that I'm facing any difficulty? I'm not. That's just because I have used NumPy so much. Same way you guys need, that's why there are many quizzes, guys. That's why there are many quizzes. And even in the platform, when it becomes live for you, I think there are more practice questions. Please practice NumPy. When we move to pandas and all of that, we will have to learn other things, data analysis and data science related things. So it's better to practice this when we have the chance, and then little by little we'll keep improving. Okay, great. We've discussed addition, subtraction, division, multiplication. What other mathematical operations you can think about? Exponentiation, right? And I hope we all know the basic exponent. For example, what is 4 power 2? I hope, do we all know the symbol, guys? Double star. We all know double star exponentiation. Okay. So 4 star 2, 16. Right? This is 4 power 2. 2 power 3, 8. Okay. Then minus 2 power, why minus 2? Minus 3 power 5, minus 243. Okay. This is exponentiation. All right. Now suppose I have this array again. I have a NumPy array. Here I have taken 2 rows, 3 columns, 1, 0, minus 1, 2, 0.5, 0.1. And suppose I square the array. So notice what I'm doing here. I am taking the full array and I'm squaring the array. What do you think is going to happen? Each of these elements will be squared. That's exactly what will happen. 1 power 2 is 1, 0 power 2 is 0, minus 1 power 2 is plus 1, 2 power 2 is 4, 0.5 power 2 is 0.25, 0.1 power 2 is 0.01. Again, very straightforward. Okay. Not an in-place operation. Does not change the original object. So if you want to change the object, reassign. Okay. So I'm reassigning the result to the object, and now I have the squared array. Now how do you get square root? In mathematics, how do we get square root? Power 1 by 2. Correct? Cube root is power 1 by 3. So same thing. If I take this array and then do square root, which is power 0.5 or power 1 by 2, that will give me what? Square root of 1 is 1, square root of 0 is 1, square root of 1 is 1, square root of 4 is 2, and so on. Notice that it only gives me the positive square root. Okay. For, negative, positive, and things like that, you can explore a little bit more advanced NumPy operations, but right now, not necessary. Okay. So square root operation, it's just power 0.5. Again, this is not going to change the original object, so I can reassign and print. So what happened here to here? I have this array, I squared it and I got this array here, and then I did square root, I got back this array. Okay. Now of course there is a method called square root np.sqrt. This is a very common method which is used. So if you do not want to use power 0.5, you can use the more advanced method, which is np.sqrt. Okay. So you can read more, by the way. In Jupyter, whenever you open a method like this, you just click inside the bracket, just put your cursor just next to the first bracket, and you can press shift tab. I hope we all know that in Jupyter. So if you press shift tab, you will get commands and parameters and a bit of documentation. I think there are some examples. Okay, examples are not here. Examples you can find in the documentation page. Anyway, so np.sqrt is a very common method used in NumPy, which is nothing but square root. So now if I take this array and I do np.sqrt of this, that is going to give me the square root of each of these numbers. Okay. Again, this method is not in place. Okay. Again, the phrase I keep using is in place. Okay, this is what I'm saying, in place. These operations are not in place. They don't change your original object. So for example, if you print np array again, it has not changed. Okay, a lot of these operations are not in place. So if you want to change, then you have to assign. All right. So just wanted to give a little bit introduction and insight into exponentiation also. Right. It is not so different from addition, subtraction, multiplication. It behaves in a very similar fashion. All right. Okay, great. I do have a homework quiz here, which you can try it later. Now, maybe we can take a small break here and then reconvene, because now we'll be doing more statistical. So up till this point, we were doing basic mathematics. In other words, basic mathematical operations on NumPy arrays. Now we will get into a bit of statistical operations, right? This is where the entry into data science begins, so to speak, right? Actual entry into data science activities, data analysis activities starts with the statistical operations in NumPy. Okay, that is from here. So in the next part, we will be doing statistical operations and what some of the other methods. We have some interesting methods. So up until this point, we have discussed, um, you know, structure of NumPy arrays, basic operations such as addition, deletion, replacement, accessing, indexing, those kinds of things, right? And we also saw basic mathematical operations that can be performed between arrays, right? And we also saw some broadcast operations, which applies to all the elements in an array. Okay. Now we'll start with statistical operations, right? Which kind of leads into what we are going to be doing tomorrow and possibly day after in pandas, right? This is where data analysis, data science, all of that starts, right? Essentially data analysis, data science, these are statistical methods applied to real data, essentially. So let's start with some of the very basic statistical methods, right? So suppose I have this array here, NPR, which is 1, 2, minus 3, 5, 6. Okay, so there is a method associated with the array object called sum. Okay, SUM. And obviously, I think we all know what sum is supposed to do. It's essentially going to add up all these elements. Okay, so start thinking in terms of your own domain data, right? If you're from finance background, you must be adding revenue values or profit values, something like that. If you're from management, you might be adding some other kind of values. The very notion of addition of numbers is a kind of statistical operation, right? In maths, you can call it addition. In statistics, we call it aggregation, right? What is the aggregate of this group? So this is where, as you can see, we are getting into the whole concept of data analysis, right? So one of the most basic statistical operations is sum. So if I just do npr.sum, it's going to add all these and give me. Okay, 1 plus 2, 3 minus 3, 0, 5 plus 6, 11. So nparray.sum is giving me 11. Okay. Suppose I take two-dimensional. Okay, now I have 1, 2, minus 3, 5, 6. And then I have one more row, minus 4, 3, 2, 5, minus 2. What is going to happen if I do nparray.sum? It is actually adding all the numbers and giving me the answer. So it is doing 1 plus 2 minus 3 plus 5 plus 6, which was 11. And then minus 4 plus 3 plus 2 plus 5 minus 2. So that's minus 1 plus 2, which is 1. 1 plus 3, 4. 4 plus 11 is 15. So on the back end, what is going on is it is collapsing to one dimension. Okay. So when you do something like nparray.sum on a multidimensional array, it is collapsing to 1D and adding everything. Okay. It's as simple as adding all the numbers. Now, typically in data science, we don't want to just add all the numbers, right? Suppose we have one dimension, which is say nationality of a customer, right? And suppose another dimension is gender of the customer. So now I can do an analysis, which is give me the expenditure by this nationality. So how much are the Indian customers spending? How much are the American customers spending? So on. I can also ask the question, how many are the male customers spending? How many are the female customers spending? How much, sorry, are the female customers spending? So typically in data analysis, we are interested to have control on the axis on which we are applying the statistical operations. Okay. So which is why most of these methods, if you see sum and all of the other statistical methods, they will have a parameter called axis. And remember, axis equal to 0 means row, axis equal to 1 means column. So now when I do NP array sum with axis equal to 0, okay, for NP array, and if you want, we can just print NP array here. Okay. So you might think that, one row got deleted or something, but no, that's not the way to think about this. What it has done is it has collapsed the rows into, the columns into one dimension, right? So what it has done is it is preserving the row dimension. So 1 minus 4. It's collapsing the row dimension, sorry. So 1 minus 4 is minus 3. 2 plus 3 is 5. Minus 3 plus 2 is minus 1. 5 plus 5 is 10. 6 plus minus 2 is 4. So what it has done, it has applied this operation along the rows while preserving the columns. So this sum operation has been applied along the rows. Okay. So these are your rows, 1 minus 4. So think of it this way. Column number 0, how many rows? Row 1, row 2. Or in Python language, row 0, row 1. So column number 0, all rows has been applied sum. So 1 minus 4 became minus 3. Then column number 1, again all the rows apply the sum. 2 plus 3 is 5. So what you have done is you have added all the rows for each column. That is what axis equal to 0 is doing. The sum operation is applied on the row elements for each column. Same way, if I do NP array sum axis equal to 1, now I think we can all guess the answer. What is going to happen? It is going to apply sum for all columns in each row. So now the answer should be just two numbers, isn't it? Row 1 sum and row 2 sum. And if we remember the sum, it is 11 and 4, I think, right? So suppose I do this, now I get 11 and 4. Okay. So axis wise operations are very important typically in data analysis. And we won't just be doing summation, we will be doing mean, median, all sorts of other kinds of analysis, right? So that's very important to note that we can do operations axis wise. Again, just to show you that these are not in place operations, they only give temporary output. So this is my NP array, which is still the same as the original. Similarly, we have this method called product. Now typically in data analysis, summation, mean, median, transformations, these kinds of things are more common. Product is not so common, but still we have the method. As I told you, NumPy is a universal package. It will have almost all the methods, mathematical methods and statistical methods that are out there. So product also behaves the same way. Suppose I do nparray.product, just without specifying the axis. Then it is going to multiply all the numbers. So I'm getting minus 43200. What will happen if I do axis equal to 0? It is going to apply product across the rows for each column, right? So it's going to do 1 into minus 4, 2 into 3, minus 3 into 2, 5 into 5, 6 into minus 2, right? So minus 4, 6, minus 6, 25, minus 12, right? Minus 4, 6, minus 6, 25, minus 12. Similarly, if I specify axis equal to 1, it will multiply these numbers. That is giving you minus 80, and these numbers gives you 240. Okay. Now, of course, the most common and the easiest and the simplest statistical method is the mean. And for those who are still wondering mean versus average, there is this very big unjustified debate, I would say, that what is the meaning of mean and what is the meaning of average. Statistically, the correct word is mean. Okay. In mathematics, the word we use is mean. Average is more of a English kind of word, not really a technical statistical word in pure statistics. Okay. Mean is the correct word, which is why in all the methods, you will find the actual statistical term, which is mean. Okay. Average is more of a informal term that we use, but the real terminology is mean. Now, suppose I do nparray.mean. What is mean? I think we all know what mean is. Mean is nothing but total sum divided by number of elements, correct? Now, in this case, what was our total sum? Total sum was 15, I think, right? Total sum is 15. How many elements do we have? This is 2 cross 5, so I have 10 elements. What should be the mean? 15 divided by 10, 1.5. So when I do nparray.mean, I will get 1.5. Similarly, you can apply the axis parameter. So axis equal to 0. What it's going to do? It's going to get mean applied along the rows for each column, right? So for column 0, it's going to take row 1 plus row 2 divided by 2. Then for column, see guys, I'm going to interchangeably say row 1, row 0. Okay. I hope we are all comfortable with this language. Sometimes when I say row 1, I'm talking about the 0th row. Sometimes it's the first row, but this is something that we all have to live with. Okay, so sorry for that. Let me just correct myself. What this is going to do, it's going to do column number 0, row number 0 plus row number 1 divided by 2. Column number 1, it is going to do row number 0 plus row number 1 divided by 2. So 1 minus 4 by 2, 2 plus 3 by 2, minus 3 plus 2 by 2, 5 plus 5 by 2, 6 minus 2 by 2. Why divide by 2? Because you are applying mean, right? You are applying statistical mean, whose formula is sum of elements divided by number of elements. So I will get what? Minus 1.5, then 2.5, then minus 0.5, then 5, and then 2. Okay. Minus 1.5, 2.5, minus 0.5, 5, 2. Similarly, axis equal to 1, if you do, it will take the mean of this and mean of this. And we know this is 11, so 11 by 5 is 2.2, and this is 4, so 4 by 5 is 0.8. Okay, so 2.2, 0.8. Okay. Yeah. That the operation that you're trying to apply, and when I say operation, there are multitude of operations. I have shown you some operations. I have shown you sum, I have shown you product, I have shown you something else, maybe I forgot, mean. Yeah. So there are many operations that you can do, many statistical operations you can do with a bunch of numbers, right? All of these methods require a bunch of numbers. Axis is specifying which bunch of numbers do you want to apply the operation to. In one dimension, there is no question. There is only one set of numbers. In two dimension, you can see sets of numbers in two different ways. Okay. For example, if you take this array, the one that I'm highlighting, I can look at it in terms of 2 rows of 5 numbers, or I can look at it as 5 columns of 2 numbers. Correct? Now to just improve that language, I can see it as 2 rows of 5 columns, or I can look at it as 5 columns of 2 rows. Did that make sense, guys, everyone? 2 rows of 5 numbers is the same as 2 rows of 5 columns. Same way 5 columns of 2 numbers is nothing but 5 columns of 2 rows. Okay, now we are making the language more formal. So when I say axis equal to 0, I am saying apply the operation on the rows of each column. Whatever operation I'm specifying, apply to the row elements of each column. That is axis equal to 0. Axis equal to 1 means what? Apply to each column, right? Apply to all the columns of each row. So there are 2 ways of looking. The first way of looking was 2 rows of 5 columns each, right? That way of looking is axis equal to 1. Okay, 2 rows of 5 columns each is axis equal to 1. So each row I'm looking at it as a set of 5 columns, axis equal to 1. Then when I do dot sum, it will summation the 5 columns for each row. Okay, I think this makes clear. If I look at it as 5 columns of 2 rows each, then that is axis equal to 0. Okay, so then if I say do summation for axis equal to 0, for each column it will pick out the 2 rows and it will apply the summation on the rows of each column. So just to summarize, axis equal to 0 means what you're doing is you are applying operations on the rows of each column. Axis equal to 1 means you are applying the operation on the columns of each row. Okay, so just think about it that way, right? And just to make the language even simpler for everyone to remember, collapsing rows means axis equal to 0. Collapsing columns means axis equal to 1. Yeah, great. Okay, and by the way, I hope we appreciate that. If you apply summation on the row elements, it will collapse the row. Correct. So if I have one column with 2 rows, and if I apply sum, it will collapse the 2 rows into one number. Okay. Yeah. All right. Right. So let me demonstrate this with a question here. Okay. Um, so suppose I have coordinates of 2 points in 3D space. So this is 3-dimensional space, and these are my coordinates. This is from coordinate geometry in mathematics. I hope you all remember. Okay. So my first point. So this is my x value, y value, z value. I hope we all remember this XYZ business. What is this array 339, Anusha? You did some subtraction, didn't you? Okay, subtracting the coordinates does not give you the Euclidean distance. NP dot square root of 0.2 minus 0.1 squared. You forgot one small thing, Anusha. You're almost at the correct answer, but you forgot one thing. What did Anusha forget? Can anyone just see that? And guys, let's have open discussions, okay? Then only we are all learning. There's one small thing that Anusha forgot in the formula. Anyone can identify? Almost correct, 90% correct. Point number 2, x coordinate is 1, y coordinate is 0, and z coordinate is -4. Okay, now if I remember my Euclidean distance formula correctly, I need to do x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square. And then I need to take square root. So Anusha, I think you understood. Are you getting the hint? What you missed? What did you miss? Summation. Exactly. You missed summation. Okay. So here what I can do is 0.1 minus 0.2. Okay. First thing I need to do is square, and I'll print these results one by one so that we can all understand step by step. Okay. So here's my 0.1, here's my 0.2, and I need to first of all do 0.1 minus 0.2 square, which gives me this 9981. The next thing I need to do is summation of this result. So what I need to do is 0.1 minus 0.2 square, which by the way, the result from this operation is an array. I hope we can all see that. When I do 0.1 minus 0.2 square, right, it's giving me array. The moment I can see an array, why should I store a new variable? It's an array. So all I need to do is put it inside another set of brackets, and I can directly use array operation dot sum. An array, right? The answer from here is an array. So I can do directly dot sum. The only thing is you need to put one set of brackets. Okay. So array 9981 dot sum, which means 9 plus 9 plus 81, which is 99. Now I need to do square root of this, and we have used np dot square root, which is fine. So np dot square root, and I take this whole operation and I'll put it in here. So the Euclidean distance between these 2 points is 9.95 something. All right, it is clear. And by the way, Euclidean distance is used almost in all places when you deal with things like machine learning. Anyway, so as I said, we will spend a lot of time in the initial part of the program becoming masters of the tools, and slowly we will start implementing in the various concepts. And as I said, I think someone asked me last time, when we go to the concepts, it is assumed that you know all the tools. Okay. Anyway, so that was pretty straightforward, wasn't it? So this is the thing, right? NumPy, you cannot do this in one statement like this with lists and things like that. You cannot do this with lists. Okay. Which is exactly why NumPy came into existence. It is a universal mathematical library, right? So it was, so you can say that list, string, tuples, these are all very general purpose programming objects, right? So it is more generic. On top of that, you have a subsection called NumPy, okay, which uses all this, of course, but it is specified for mathematics. Okay, there are some couple of interesting questions here, which I will let you guys to solve it later. And let's look at some other interesting methods in NumPy. One of the very typically used method is round, because whenever you're dealing with reporting data, whenever you're dealing with things like storytelling, things like data reports, it's not nice to see values like 9.94987437 in your report, right? It doesn't look that good. So NumPy gives you round operation also. And notice, okay, again, just to iterate the point, NumPy is not just about vector, advanced mathematics, nothing like that. NumPy is about all mathematics. So even the simplest kind of operation that you can think of in mathematics, rounding a number, even that is specified as a proper inbuilt command, right? So here the method we are using is numpy.round. You can specify your input array here. You can also specify the number of decimal points to retain. And notice that again, this is a broadcast operation, right? It will apply to each element. Okay. So in this case, I have 1.56, 2.765, minus 3.33, 5.102, and all these numbers. And I'm just giving you the name of the parameter here. Again, you can use Shift Tab to check what are the parameters of this method, and then you can go study the parameter. Okay, what does it do? Things like that. And you can even check the documentation later. I highly recommend, right? Once we are all somewhat comfortable with the basics, we should start exploring the actual documentations of all of these libraries. Okay, so NumPy documentation is well documented, extremely well documented library. So just go Google NumPy documentation, you will get the whole thing, right? Anyway, so the parameter of the input array is called A for whatever reason. So one thing that I would advise everyone when you are looking at documentations, when you are studying these methods and parameters, don't worry too much about the parameter names. Sometimes somebody would have given the name A here. In some other method, the actual input would be called input, or some other method the input may be called ARR. Okay, these things happen. Okay, but what is important is to understand what is the input. Okay, so the input here is the array, and there is a optional parameter, okay, which is the number of decimals. So if I round my NP array to 2 decimals, what is going to happen? I will get 2 decimals. So if you see 1.56 rounded to 1.56, 2.765 rounded to 2.76. Why? Do we all know the international universal rounding rules? If there is an even number here, then when there is 5, it will not change to the next number. If it's odd number, it will change. Correct? So these are universal mathematical conventions. Right? All that is encoded in these NumPy methods. Okay, so numpy.round. And again, it is not an in-place operation. Right? You have to assign if you really want to change. Okay. So now if I round it to 2, I will get this array. Now again, if you directly round it without specifying decimals, it rounds to integer, because the decimal default value is 0. So when you round this array without specifying the decimal parameter, it will round everything to integers. Okay, so then you can store it in a variable or whatever. That's fine. Now I've given a very interesting example homework here. This is similar to your Euclidean distance. I would urge learners to try this later. I would urge everyone to try all the quizzes later, actually. Right? And this is regarding the area of a triangle. So this is quite an interesting one. This will kind of motivate you to try to use multiple operations and commands, whatever you have learned. So this question, definitely a must try. All right. Okay. So let's move on to some other examples of functions in NumPy, methods in NumPy. So we have seen basic methods. Where are they? Yeah, we have seen basic statistical methods like sum, product, mean, and things like that. Of course, there are others. Now, I'm guessing everybody is wondering, is statistics only mean, product, and sum? No, obviously not. But my point is that we will be learning other methods as we go ahead, and all of that is built on NumPy only. So when we do pandas, when we do EDA and all those other topics that we'll be doing, we'll be using all these statistical methods, right? Either we'll be invisibly using by using the method from the pandas library, for example, which is built on NumPy. So I might do pd dot median, right? Pandas median, but that's actually built from NumPy median. Okay. So same way when you do EDA also, you might use, this is a case where you're using it invisibly. You might even use a different NumPy method somewhere later where it is required, in some data analysis. And that time you may do it visibly. Okay. So this is just an introduction to the set of statistical methods. In fact, if you go to the documentation, it will give you the full list of available methods will be given. You can check that out later. Yeah. So again, back to the thing. So what we saw axis wide methods or axis operations, we saw sum, we saw product, we saw mean. We can also customize axis wide operations. Very interestingly enough, we can customize this stuff. Okay. So suppose I have an array, right? 1, 2, minus 3. I think we've seen this array before, right? Same array. So this sum is 11, this sum is 4, whatever. It's the same array. Now suppose what I want to do is, I want to do a custom operation on these numbers, right? So I'm defining a function here, and what I really want is I want to square the number and add 5. So I want to, square 1 and add 5. I want to square minus 4 and add 5, right? So suppose I define this, right? Num transform x, you should return for me square plus 5. Okay. So suppose I do this. Okay, this function is defined. Now there is a method called np.apply along axis. Okay. So in this, what you can do is you can provide your user defined function, and then you can specify the axis that you want to apply and give your input array. Okay. So here let us see what the output comes out to be. Now in this case, because you are doing an integer operation, it really doesn't matter. This axis parameter doesn't matter because you're doing integer operation, right? So if you see the documentation, here it says axis integer, axis along which array is sliced. Okay. But this is an integer operation. You're taking x, which is 1, and then you're squaring plus 5, and then 2, and then squaring plus 5. So what is 1 square plus 5? 6. What is 2 square plus 5? 9. What is 3 minus 3 square plus 5? 9 plus 5? 14. So it is it's just taking all of these numbers and it is squaring and it is adding 5. So I can, achieve the same thing by doing what? I can just achieve the same thing by doing this, right? NP square plus 5, because this is a broadcast operation, right? I can achieve the same thing by doing just broadcasting. Now, where this starts to, make more sense is when you do statistics. So now if you see here, the same function I'm redefining, but now I'm assuming x not to be integer, but I'm assuming x to be a slice of an array. Either it is a column slice or it is a row slice. So either it's one column or it's one row. Now supposing my input is either a column or a row, then I can actually apply basic statistical aggregation methods on that slice, right? And then I can apply this custom function on my array. So here I have done what? np.mean x plus 3. So for example, suppose I take this 1 minus 4, which is minus 3, and the mean of these two is minus 1.5. So minus 1.5 plus 3 is 1.5. So if I apply this to collapse the rows, which is axis equal to 0, then I will get 1.5 plus 3, which is 4.5, right? 1 minus 4 is minus 3, divided by 2 is minus 1.5, which is this value here. Okay, collapsing this these two rows plus 3. Same way you can do for axis also. So let's see how this works. So suppose I define this. Now again, I'm applying this function. I'm passing this function name to the argument func1d, right? And notice that these functions are applied on one-dimensional slices, which is why the parameter is called func1d. Here I'm specifying axis equal to 0 and input is NumPy array. If you see the output, what has happened? Axis equal to 0 means what? You are collapsing the rows, right? So what it has done? It has taken mean of 1 and minus 4, which is 1 minus 4 divided by 2, right? Minus 1.5. plus 3, which is 1.5. Then 2 plus 3 divided by 2 is 2.5. 2.5 plus 3 is 5.5. Okay, I think you are getting the pattern. So you have applied this custom function to collapse the rows, axis equal to 0. Same function you can now apply with axis equal to 1. So in that case, what will happen? It will take this mean and it will add 3. So the mean of this, if I remember, it is 2.2. So 2.2 plus 3 is 5.2. Again, mean of this is 0.8 if I remember. So 0.8 plus 3, 3.8. So now same function, if you apply on axis equal to 1, you will get 5.2 and 3.8. Okay. So just wanted to show that you can customize your own functions, and this will become more important when each of you is more involved in your own domain and your own data analysis in your own domain. You will be having various functions which I don't need. For example, right, if your domain is finance, then you might be having a lot of operations which you will be using, right? But if I am working in weather sciences, then I'm going to have various operations which don't really are not of use to you, right? So this is quite important when you do get into your own analysis. Okay. Now again, this np.apply along axis is a NumPy method. Typically in data science, as I said, this is now used to build more user-friendly functions. For example, in pandas we have something called .apply. Okay, so it uses this NumPy as a base, and it the same behavior is inherited to the libraries which are built on top. Okay. It's good to know what's happening though. The whole point is it's good to know what's happening here. Okay. No, I mean, yeah, you have to pass a function, Anusha. Customized operations using apply along axis. If you're talking about this method, apply along axis, then yes, you have to define a function. It needs to have a parameter, output, all of that. It needs to have return. Yeah. So it needs to have a name. It needs to have a return. Okay. That's why it's called func1d. You can directly use something like np.main, I think, right? Because it is a function, right? You can just try np.main. It may or may not allow. You can try it on your own, right? But typically np.main is a function. So if I directly use np.main here, it should work. It is working. See, it's working. Anything which is a function can be passed into the argument, right? func1d. So now you check the documentation. Here it says, it will tell you what is func1d. Apply a function to one-dimensional slices. Func1d. It's a function which takes a set of parameters to a result output. Okay, so this is obviously your tuple, and I hope we all understand now that the input to a function is a tuple, right? I hope you have all studied functions. So in this, you essentially you have a tuple of input parameters, right? So that's what it is telling me in the documentation. Here, if you see, it says that the function which takes input tuple, parameter tuple, and it produces some output, right? This function should accept one-dimensional arrays, obviously, which is why np.main is working. Okay, if you think of a function which does not work on one-dimensional arrays, then it will give an error, right? So yeah, you can use predefined functions, you can use custom functions. You need to use functions. For this method, you need to use functions. All right. Now in data analysis and typically in programming also, it's quite important to generate numbers. In many cases, we'll be generating numbers. So there are some very standard basic methods to do that. So I think we all know this range method. Are we familiar with range in Python? Is everyone familiar with range? So if you do range 2, it says it's a range. Now I can actually try type range. Type range is range. Okay, so it's not a list. The range method, it's what you say, it's a direct Python method. It's not a library method. So same way, you have int, you have float, you have range, You have sum also, right? All of these are direct Python methods, not associated with any kind of library. Okay, so you will see it become green color in Jupyter. I don't know Colab. I use very sparingly Colab. Mostly I use Jupyter, but yeah, you can see this green color, right? So this range thing, the output is range. Now, how do you get a list out of this, right? Maybe you can do list range to, yeah, that gives me 0, 1. Okay, so this range thing is a range object, then you convert to list, you will get list. So NumPy, what does it do? It takes this and creates a very universal function out of it, right? That's what NumPy does, right? It takes this whole behavior and it generates an array of numbers for you. Okay, so that method is called arange. Okay, np.arange, and this is such an important method. We'll be using it so many times. So it follows the same typical indexing of Python. So there's a start number, there's a stop number, and then there's a step. Stop number is exclusive. So if I do, yeah, it's basically like indexing. Yeah, the only thing is you can produce any number in this. Okay, let's see that, not just integers. Okay, so here start equal to 0, stop equal to 5, step equal to 1. It should give me 0, 1, 2, 3, 4. Array 0, 1, 2, 3, 4. And of course, you don't need to use the parameter name each time. If you remember the correct order, then you can directly skip the parameter name. So here, if I do np.arrange -10, 0, 0.5, what is this going to do? It's going to start at -2. It will exclude 0 and it will go in steps of plus 0.5. If I do this, I will get -10, -9.5, -9, -8.5, so on, so on, so on, till -0.5 exclusive of 0. If you do not specify the third number here, which is the step, the default is, I think, 1. So we can check that. Step default is 1. See, the default step size is 1. So if you don't specify step here, you will get 0, 1, 2, 3, 4. Start number and end number. So, and my point is, you can actually use this to produce any kind of evenly spaced range. Okay. So this is, a very typical common method that that we are using in NumPy. Another similar method is called linspace. So this becomes important when you try to do a bit more advanced visualizations, right? So usually these kinds of methods are used to define axes. Okay, so for example, if I want an x-axis which starts at 0, stops at 1, and the total number of numbers is 2, then in this case I'll get 0 and 1. Notice that for linspace method, this 1 is inclusive. Okay, this is slightly different method. The stop is included. So basically what this method is doing, from 0 to 1, I want two numbers inclusive of 0 and 1 which are evenly spaced. So it gives me 0 and 1. Now if I say from 0 to 1, including both, I want 5 numbers which are evenly spaced. So then I will just change num to 5. Now you get 5 numbers including 0 and 1 which are evenly spaced, 0, 0.25, 0.5, 0.75, 1. Okay, pretty simple method, right? Again, you can do the same thing from 0 to 1. I want 50 numbers. And one thing that you should remember in mathematics is when you include the starting and the ending, then the total number of numbers will be +1 if you are evenly spacing, right? So if you do 50, then what's happening is total you have 50 numbers, but the space between number is 49. So if you have 50 numbers, just think of 50 points on a line. How many spaces are there between the points? 49. So if you want to look, if you want to clean, numbers, if you don't want these kinds of very bad float numbers, of course, this is also going to be float. But if you don't want these very weird numbers, then if you put num equal to 51, then it will give you really clean numbers. Why? Because now the number of spaces is 50. So what I'm trying to say again is this is the number of numbers, not the number of spaces. So that's one thing to keep in mind, because this is inclusive, right? In this linspace method, the stop is inclusive. Okay, so these are like the two most common pattern producing methods in NumPy. One is arrange and one is linspace. Okay. All right. Can everyone create this array now using either of the methods? Please try solving quiz 26. Sri Prakash, that's a really good question. Does it take float by default each time? Answer is no. Look at this. np.arrange 0,5 with step 1. Can you see there is no 1 point? See, there's no 1 point, 2 point, 3 point. The point is not there. So this thing, if you just do type, that will be array, obviously. Sorry. If you do the first number, then type, that is int 32. Okay. So no, each time it's not going to be float. It will take the data type which is more suitable, basically. And if I'm not wrong, I can get the type from the array. So int 32 is the data type of the data inside this array. Now, if I just change this to 0.5 step, then it will be float 64. It is taking the suitable data type for the array that is being created. Okay. Right. So, all right, back to quiz. Can everyone try solving this? Use any of the method and produce this array. Please put your answer in the chat. Yeah, this array is going from -7 till 4, and it is going in steps of what? NP arrange -7, 4.5. So yeah, Rajat and Ashish both have given me the answer here. So let me try. NP arrange start number is -7, end number exclusive is 4.7. So when you're using arrange, you are excluding 4.5. That is good. So in steps of 0.5, it will exclude 4.5. Therefore, it will stop at 4. Correct. Yeah. So -7, -6.5, -6, da 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 da. It goes till 4. Okay. Great. Can we try quiz number 27 now? Create an array with 20 entries, starting with number -10, ending with number 10. What is the command for that? So these quizzes are here to motivate you to choose between these two methods. Which is better? For which case? np.linspace -10, 10, 20. Yep. So I think the inclusive part is hidden in the English here, right? It says starting with the number -10 and ending with the number 10. So if you read this English carefully, what it is saying is include -10 and 10. Correct. So that directly tells me use linspace, right? So -10, 10, and of course it will produce 20 numbers. Okay. Quiz number 28. I'll sort of solve this and show you step by step. Okay, you can follow along. Define a function that takes in the first term and the common difference of an arithmetic progression and prints the first 10 terms of the sequence. Do we all remember arithmetic progression from school? Yeah, do we remember? It's that, arithmetic progression, right? It has a number, then you keep adding the same number again and again and again. That thing is called common difference, and this thing is called first term. Okay. So I need to define, let's say create AP, right? And I need to return the arithmetic progression. And what it has to take? It has to take in first term, suppose A, and it has to take in common difference d. All right, I need, and it has to print the first n terms of the sequence. So I have to also take the character n. Okay, not character, number. So I need to take in first term common difference, and I need to take in this variable n. Okay, first n terms of this arithmetic progression. Now, which method can I use for this? Right, I would think of using np.arrange, correct? So suppose I do ap equal to np.arrange and just directly I say adn. What do you think is going to happen? So just go back to arrange. Okay, just go back to arrange. Go to a simple version of arrange. So if what you can see here is it's excluding the last number, correct? It's excluding the last number, and we know, if you remember arithmetic progression formula, that is a plus what, n minus 1d, correct? So if I use np.arrange, first it is going to print a, okay, then it is going to print what, a plus d, then it is going to print a plus 2d, and so on. And it is going to exclude what? That is the question. It is going to exclude, sorry, this should be the other way around. This common difference should come here, and this is where what we should put. Should we put a plus nd? Should we put a plus n minus 1d? Which one we should put here? So notice that this a plus n minus 1d, if you remember, that is the nth term, and I need to produce the first n term, which means what I should put inside here is a plus nd. Okay, because this will be excluded. Here if I put a plus n minus 1d, then the nth term will be excluded, so I cannot put that. Okay, so I'll define this function. Now this is my start number, this is my stop number exclusive, and this is my common difference. So suppose suppose I do something. Suppose this is my arithmetic progression. 3 plus 4 is 7, 7 plus 4 is 11, so on, right? Suppose this arithmetic progression, and I want to produce the first 10 numbers. Now this function, if I take create ap, the first term is 3, the common difference is 4, and I want 10 numbers. D is not defined. Okay, and times d. So now it's producing, see, 3, 7, 11, 15, 19, whatever. So is it producing 10 numbers? Just check shape. Yes, it is producing 10 numbers. Hope this is clear. Okay. There's a more challenging exercise here for you guys. Okay, it is based on, I think, arrange or linspace. I don't remember, but this is quite interesting. Okay, solve it in your free time later. All right, so now we have seen, linspace and arrange for generating these equally spaced axes, basically, right? Many times when you're doing coding, you also require some placeholder arrays. You may have done similar things in your own domain before. Placeholder means something to start with, right? Then I can add numbers to it, then I can subtract numbers, whatever, but something to start with. So there is a very, very nice and simple method in NumPy, two methods, by the way, which allow you to do this. One is called zeros, one is called ones. Okay, essentially it's just producing any kind of n-dimensional array with zeros. So suppose I say np0 shape equal to 2, 2, it will produce 0, 0, 0, 0 of shape 2 by 2. Suppose I do 2 by 5, it will produce shape 2 by 5, 0, 0, 0, 0, 0, 0, right? So whatever shape you want to give here, you give 2, 3, 4, you give 3-dimensional. It will produce the same shape with all zeros inside. Okay, so that's the zeros method. And the argument I'm passing is shape. Okay, so you can directly, just pass this value. You don't need to necessarily call the parameter name each time. You can directly pass this value. So for example, np.zeros, 2, 5. Okay, so this is giving like this. One thing to remember again is that this is a tuple. So when you do, so this is where tuple interaction becomes a bit complicated, because np.zeros is also a function. The input to a function is also in the format of a tuple. and the parameter in this case is shape of NumPy array, and we know that shape is also a tuple. So now if you don't correctly specify the shape tuple, then it will try to understand the function tuple. So here if you see these brackets, that is for the tuple of the input parameters of the function. Okay, but I want only one input parameter, and that input parameter itself is a tuple. So that is why I need to use double bracket. Okay, so these two things need to be put inside a tuple. Then it's one parameter, right? This is going to be one parameter which is taken into the parameter shape. Okay, great. So when it's not a tuple, when it's an integer, then it's okay, obviously, right? When it's an integer, it's not a problem, right? And let me also take this opportunity to show you how to write an integer as a tuple, because you can put this integer inside two brackets like this. You can also do comma with space. So typically if you've seen in Python, one-dimensional tuples are represented as integer comma something, right? So if you do NP array, and suppose I just have a one-dimensional array here, okay, 1 2 3, and I do dot shape, you must have seen this many times, right? So this is a tuple with only one dimension, right? This standard convention. So you can even use that convention here if you want, but obviously it's just much easier to just put the integer in there. Okay, what do you think np.once is going to do? It's going to produce ones, that's all, right? So whatever shape you give, it will produce ones. There are other related methods like I and identity. I will leave it for you guys to explore in your free time. Okay, and there's a very simple question here which I think you can do it yourself. Okay, great. Another set of methods which are quite useful is random number generation. Now you must be familiar with the Python, I think rand. Okay, so you can there is a package called random. Okay, this has some random numbers and things like that. What is NumPy going to do? It's going to build on that, and it's going to give a universal set of random numbers. Now I'll not go more into detail into the nature of random numbers right now. Okay, this is something that you will study later when you do probability and all of those things in the program, right? When you do probability related statistics, that time it will become more clear. But let me just show you a few methods. So this is the package within the library. So there is numpy.random. Okay, it's a module within the numpy package which is specifically designed for generation and handling of random numbers. So the way to call it is np.random, and then there are many functions inside like randint and things like that. So what do you think randint is? Randint is nothing but it produces random integers. And the parameters here, if you see, it is low equal to 1, high equal to 5, size equal to 10. What is the meaning of this? Produce 10 random integers for me, okay, between 1 and 5 excluding 5. So as you can see, it has produced 10 random integers for me between 1 and 5 excluding 5. So 1, 2, 3, 4. You just run it again, you will get different. Run it again, you will get different. And these things, again, as I told you, these are used in backend when you do things like sampling. You know, when you go to inferential statistics and things like that, you have to pick random samples from data, right? So all of these methods are inbuilt in some of the methods that you will be using there. But in the backend, it's all NumPy. Okay. So again, if you want, you can also produce negative integers. Here, size equal to 1, which means from minus 10 to 16, produce me a random integer. But notice that the output is array only. So if you want to extract this number, then you have to do bracket 0, right? Get the first number in the array, right? And if you don't do this, you will get the array. Each time you will get array. Okay. So randint produces random integers or arrays of random integers. What does rand do? Now this is a very interesting function. It is producing between 0 and 1. So if you keep running it again and again, you will see that you are getting numbers between 0 and 1, right? And you can specify, and in fact, this thing has the parameters are essentially the sizes of each dimension. In other words, it is the shape. Okay, so Here you don't need to put double bracket. Here you can directly put the shape that you want. So 2, 3. So if I do np random ran 2, 3, it gives me 2 cross 3 array with random numbers between 0 and 1. So here there is no necessity to put double bracket. Okay. So here you can see tuple object cannot be interpreted as integer. The reason for this is that the function is designed that way. Okay. So which is why I make it a point that you should all look at the documentation when you get the chance. So if you see here, it says D0, D1, dot, 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 Dn. So obviously these are the sizes of the dimensions. So if you remember the image file, that is 25, 32, 3, right? So D0 is 25, D1 is 32, and then D2 will be 3, right? You don't need to put a tuple as the input in this function, which is why it's important. Now, if what was the other function? If you go to ones, here if you say, it says shape is the parameter. Here you have to give the tuple. Okay, so always make sure to check the input parameter, what is expected by the function. So anyway, so you can generate like this, random numbers between 0 and 1. So these are some common random number generators that are used, and of course a lot of the other statistical methods will build on these basic methods. Okay. Some additional statistical methods which are of use in data analysis, which we will see in much more detail when we do pandas. Here I will just give a sneak peek kind of thing. Is the max and min, right? So we know what max and min is. Max and min is nothing but maximum and minimum value. So I'm just using, np.rand and np.round to create a random array. Okay, here I've created a 3-dimensional array. Notice I have used np.rand and then np.round, and I've put all this together to produce random array. I can, run it again. It will give me slightly different array. And if you don't like these floating point numbers, then just round it to integers. Okay. And if you, do not like the points, the 10 point, 39 point, 57 point, if you don't like that, then just put this array result inside another array command and specify your data type. The type equal to int. This should work. Yeah. So now I have nice integer. Okay. So notice how I'm chaining commands. Okay. This is something that we have to start getting familiar with. Okay. All these bit by commands are very tiny commands, right? It is what's it doing? Rounding, random, collapsing. All of these are very precise pinpoint commands. So when you do a more holistic thing in data analysis, when you do for bigger analysis, you need to learn to chain these commands. Okay. So I've chained all these commands and produced this array here. Shape is 243. Okay. Now what will happen if I do np array dot max, right? So this array np array dot max. So if I do max, it is essentially giving me the maximum value, that is the maximum integer or maximum number, I should say, not integer, maximum number in the array. So in all of the numbers, 99 is maximum. Minimum is 1. Interesting. So minimum number is 1. Notice that this maximum minimum functions are also axis wide operators. So suppose for the same array, this array, if I do np.array axis equal to 0, what happened here? And we try to interpret this. So what it has done is it has collapsed rows, but it has given me the columns which have the maximum value. In other words, and maybe this is a bit hard to see in 3 dimensions. So maybe we will go for 2 dimensions, right? So suppose I just change it to 2 dimensions. Now I have this 2 cross 3 array, and now the maximum value is 95, minimum value is 8. Okay. Now if I do maximum axis equal to 0, what is it doing? It is giving me 39, 60, 95. So it gave me 3 columns. In other words, it has collapsed the rows. But how did it collapse the rows? It retained the row which contained the maximum value in the whole array. So 95 is the maximum value in the complete array. So it's essentially, it is giving me the row which contained that maximum value. And how am I saying that it has collapsed the rows? Of course it has collapsed the rows, which is why you're getting 3 columns, 39, 60, 95. So what it has done is, it has seen this row, it has seen this row, and it has checked these two rows and selected that okay, 95, the maximum value is in this row. So it has collapsed the rows and given me all three columns, and out of these all three columns you will get the maximum number 95. It gave me the row which has the maximum number. Similarly, for this, if I do axis equal to 1, what will it do? It will give me the column, right, which has the maximum value. So in this case, it is giving me 95, and here I am getting the value 59. So it is giving me 95 and 59. Okay. Now axis equal to 2, obviously this is not going to work, right? So so column wise, if you see here, I have okay, this will obviously not work, but these two are working, right? So when axis equal to 0, 39, 25, the maximum number is 39. 60, 59, maximum number is 60. 95 and 8, maximum number is 95. So it has collapsed these columns. And then axis equal to 1, it will check column wise. So it will check for all the columns for row 1, 39, 60, 95. The maximum value is 95 here, and that is what is retained here. And similarly here, 27, 59, 8, what is the maximum value? 59. So that is produced here. Now same thing, if I rerun my code again, suppose I have 81, 85, 11, 39, 79, 82, right? The global maximum is 85, global minimum is 11, so I have 85, I have 11. What will happen if I do axis equal to 0? Again, it will check all the rows and then collapse. So 81 and 39, what is the maximum? 81. 85 and 79, what is the maximum? 85. 11 and 82, what is the maximum? 82. So for axis equal to 0, I will get 81, 85, 82. Okay. And if I do axis equal to 1, I will get in this row, right? It will collapse the columns. So 81, 85, 11, 3 columns. Collapse using which operation? Max. So max of these is 85, and then max of these is 82. Okay, so this kind of analysis is quite important when you're asking similar questions. So previously I used the example of what is that, nationality as the columns, and maybe something like gender in the rows. So now you can ask question of which nationality or which gender is expending the most, or out of these gender which nationality is expending the most, right? That kind of analysis you can do. Now if I change this back to a 3-dimensional, it operates in exactly the same way. The only problem is that it's hard to visualize 3 dimensions, but it will give you the maximum values across each of the axes. So now if you do axis equal to 2, it will give those maximum values. Minimum is very similar. Okay, so let me go back to 2 by 3, right? So now I have these numbers here, right? And of course this is not going to work. I will comment it. Now if I do min x equal to 0, if you remember, it has to collapse the rows. So minimum 56, 4 and 1, right? 56, 4 and 1. Similarly, it has to now collapse the columns. So 37 and 1. So here you get 37 and 1. All right. This won't work because it's 2D. So I don't know why this is in here. This is not required. Anyway, so this is how maximum and minimum operator also works, and it's also a statistical method, right? We will see this in more meaningful detail when we start with pandas, because NumPy can get a little abstract with all these random numbers, which is why I've just given you some examples here, right? When we do pandas, we will do very in detail analysis of data sets and things like that, using these kind of operations and more. So finally, just some additional methods. I wouldn't say these are too important or extremely important, but again, good to know some basics methods. So we've already seen appending values and things like that, right? We have seen how to append columns to the array. We've seen how to append rows to the array. Those things we have seen. You can also concatenate arrays. So there is a specific method called concatenate. Okay, so suppose I have these two arrays, 1, 2, minus 4, 3, 2, minus 5. And this array is also the same. Interesting. Let me change it. Okay. 5, 3, minus 2, 7, 8, 0. So suppose I have these two arrays. Now notice that this shape, and again, as I said, mentally or through code, always keep the shape in mind. So the shape of these two arrays is 3 by 2, 3 by 2, which is obviously visible from here. Okay, 3 rows, 2 columns. Now, if I use this method called concatenate, what it does is it will essentially just join the array. Okay, so you can put the arrays that you want to concatenate as a tuple. So here, if you see this, I have put array 1 and array 2 inside a tuple. And if you want to know more about the parameters, you can just look at the documentation. So here you can see the input arrays are supposed to be put inside a tuple, and the axis, where do you want to add. Okay, so now if I combine these two arrays along axis equal to 0, again, when you're doing sum, mean, product, max, what is happening? You're collapsing the rows. But when you're concatenating, you're doing opposite of collapse. Think of it that way, very simple. So axis equal to 0 for those methods was collapsing the rows. For concatenate, what is happening? It will expand the rows. That's all. So when I do axis equal to 0, I have 3 rows here and I have 3 rows here. Now these 3 rows will join this way, right? It will expand the rows. So 1, 2, minus 4, 3, 2, minus 5, 5, 3, minus 2, 7, 8, 0. Similarly, if I specify axis equal to 1, what will happen? Instead of collapsing, obviously it will not collapse. Collapse is something which is associated with summation, mean, aggregation type methods. When you're concatenating, it will expand. So these two arrays, now if you do axis equal to 1, it will expand the columns. So you'll get 1, 2, 5, 3, right? 1, 2, 5, 3, minus 4, 3, minus 2, 7, 2, minus 5, 8, 0. Okay, so if you do that, this is what you get: 1, 2, 5, 3, minus 4, 3, minus 2, 7, 2, minus 5, 8, 0. And of course, if you want to save it, if you want to save the value, you need to assign to some variable, because these are not in place methods, right? Temporary output only. Okay. And then there's one interesting method I thought I should add. Again, these are slightly obscure methods which you may not use too much, which is why I've just given 1 or 2 examples here. But again, it's good to know that some of these methods exist. The split method essentially splits your array based on an index position. Okay, so here is your input array, and then there's this parameter called indices or sections. Okay, now I've specified as index 1. Okay, this just means that the first row, second row. Okay, I hope that language is clear. When I say indices or a section is 1, that is the second row. So it will split across this row. So now see, you have 1, 2, 5, 3 as a separate array, and then you have this as another array. Okay, so I won't go more into this method or even these concatenate, right? These are, some of these are pretty obvious, so I would request the learners to explore, and some of these are very obscure, which you might explore only in case you have any free time left after doing all your basic fundamentals. Okay, so this split, for example, is quite rarely used. It's mostly not used. So I just put it as just a few additional methods to show you that it's there. Okay, now obviously if you go to the NumPy documentation, you will get all of these methods and many more methods. Okay, but throughout these 2 sessions, what we've done is we've covered all the basics and all the important methods. Specifically coming to the statistical methods, I have not gone too much into detail. I have shown you how it operates: max, min, sum, mean, product, linspace, right? I've showed you how these things operate. We will obviously explore all these statistical methods in a more meaningful setting, right? And it will be explored in greater detail when we do pandas. Right, so finally, just to close off this this whole journey into NumPy. Oh, and by the way, there is a quiz. I will leave this to you guys to do later. It's fine. I think there's a lot of quizzes for you to practice. Let's talk about finally mathematical constants. So as I told you, NumPy is this very universal mathematical package. So obviously it should have the value of the constants, right? So pi, I think we all remember pi from school. What is pi? Is it 22 by 7? Yeah, can the audience tell me whether it's 22 by 7, 3.14? Okay. Okay. So we all remember pi. Great. It's an irrational number. So technically speaking, it's not equal to 22 by 7. What is 180? Oh, 180 degrees. Correct, Anusha. Pi radians is equal to 180 degrees. Correct. Wonderful. Yeah. So as I told you, I have a maths background, so I got that. Anyway, so yes, NumPy, yes, 3.1415. In fact, guys, pi is irrational. Okay. So any finite decimal representation is wrong. Any ratio representation is wrong. Any finite ratio representation is wrong. There are infinite self-referencing definitions of such numbers that if you are interested, you can go Google it later. But these are irrational numbers. Now, what does NumPy do? It produces or it stores the value of these irrational numbers and mathematical constants up to some accuracy, right? Up to some precision, sorry, not accuracy. So if I just do type np.py, it is float. Okay, so it is storing pi up to, as you can see, many decimals, right? Similarly, e, do we all know the constant e in mathematics? Anyone? Have you heard of Euler constant? It's pronounced Euler, but the spelling is EULER. Okay. Do you remember e power x when you were doing the differentiation, integration, all that kind of stuff? Remember there was this function called e power x, and you differentiate e power x, you still get e power x. Yeah. So that e, that is the base. And if you remember natural logarithms, ln, the base of natural logarithm is e. Right. So that's also very important mathematical constant. So that is also stored in NumPy. So you can directly call the value of e, of pi, and things like that from NumPy. Okay, it's stored internally. And finally, I do want to talk about this thing here, np.nan. So look, null values are treated in very different ways in Python. So for example, np.nan says nan. Nan means not a number, by the way. np.nan gives you the output nan. Nan means not a number. Okay. So suppose I do plus 0. Not a number plus 0 is still not a number. Suppose I do nan plus 2. Not a number plus 2 is still not a number. In other words, whatever you do to nan, it's going to stay nan. Okay, not a number. So that's also a constant in NumPy, by the way. So I just do type nan, it says float, right? Type says float. If I do len, float has no len. Okay, obviously not. Float does not have any len. Okay. Suppose I put this inside a list and then say len. Okay, there is one item in the list which is not a number. Okay. So np.nan is a placeholder, right? It's your na value. Okay, na. Similarly, in Python, you also have this thing called none. So if I do type none, there's none type. Okay. And if I put none inside a list, then I try to do len, gives me 1. So there is one object inside here. Okay. And if I do len of none directly, none type does not have any length. Okay. So these are the some placeholders in Python. Why these are important? Well, when you do exploratory data analysis and things like that, when you do data processing and things like that, you will encounter many null values. Okay, it is very common. So when you take multiple sources of data, you put it together, you do some transformation, do some operation, all of that might lead to many null values. In fact, your data source itself might have many missing values. So how do you render missing values when you work in Python? So typically convention is to treat it as not a number or treat it as none. So there are a couple of important conventions which whole world uses. So it's good to know if you see none somewhere, if you see nan somewhere, you shouldn't get confused, right? So there are some of these placeholders which are used uh, to denote missing values, okay, which is something that you will see in later data processing, data pre-processing. Okay, I'll quickly summarize here, and I've written this down, so let me just read it. What does it say? NumPy is a library that has various subpackages. Yes, I think we can all agree it has various subpackages, random, many things. Like, in fact, if people are interested more in the math, try this subpackage. I think it is called linalg. Let me check. np dot linalg. Yeah. So there is a linalg subpackage which is linear algebra. So for example, if you remember the Euclidean distance formula, and then there is area of triangle. But first you should try without linalg. Okay, please try those homework questions and those math questions based on what you learned. Summation, broadcasting operation, all of that. Okay, try with that. Then if you want, you can explore linalg, which is also a useful sub package or sub module inside NumPy. And obviously that deals with linear algebra. So here you get direct functions for distances, for dot product, all those kinds of things. So yeah, NumPy is a library which has various sub modules and sub packages, all dealing with different fields of mathematics and statistics, right? And fitting all of this in a single session, and I believe now it's 2 sessions. So fitting all of this in 2 sessions or even in a single course is near impossible, and I think that's a fact, right? So what we need to understand is that we have been enabled and empowered to understand this package. We have been introduced to the most important and most popular objects and operations in this package from the point of view of data science, right? So now what you should think is, I understand all this, I practice all this, and once I'm good with all this, I can explore further, and I'll understand what's going on even better, right? It's a very vast package, NumPy. So here what we covered was some important basics, but as I said, you will be using familiar and unfamiliar packages and methods throughout your journey in data science, right? Unfamiliar in the sense, when you do a certain certain technique, maybe later in the program, maybe in some other topic, there may be, okay, we are using NumPy dot something. Okay, so at that point, the expectation is that you are comfortable enough with how NumPy operates, and by now I think we all know how NumPy operates, right? If I make a quiz saying what is the most important aspect of NumPy array, all of you will say shape. Correct. So now we have reached that point, right? We are familiar to some good extent with these NumPy objects, so that time it will be easier for you to understand what's going on with the other methods and things like that. As I said, it is important to understand that programming language tools are learned over multiple iterations. Overnight, I'm not going to become good with NumPy. Okay, over 1 month also, I'm not going to become a master of NumPy. Okay, it's going to take a few months, right? Which is why the program is pretty drawn out, right? So obviously, I can just teach NumPy and say do these things and blah blah blah, and call it a certificate, right? Whatever, right? No. So just to give you some perspective, I have been using NumPy and its equivalent for quite a few years now, right? So initially, my work was in MATLAB, which is different from Python, obviously. So I've been working in MATLAB, then I worked in R, and then I started with Python. Okay, now you guys have the advantage, you're starting with Python. Right? So anyway, it'll take time for mastery. So that's one thing you keep in mind, right? So we are at this stage, we are familiar with NumPy, we know the basic operations, we will do the quizzes. Okay, we are good with NumPy, right? You keep using it more, you keep understanding what's happening throughout the program. In case you're stuck somewhere, feel free to try out GPT, right? It will give you information, it will give you advice. Just don't expect it to give you arithmetic answers, right? We saw this with an example yesterday. I think there was some addition of what was that, some transpose of array, something. It was not able to understand 1723 right? So don't expect too much arithmetic results and number based results from GPT, but you can expect code, you can expect logic. Logic in the sense, it will teach you how a command works, right? You can expect things like that. So GPT, of course, you can use for that. And I would also urge everyone to If you have some minor doubts and things like that, use the upGrad discussion forum. If you have slightly more complex things, you can put it here in discussion forum. You can also go check Stack Overflow. Maybe somebody already solved the problem, right? So there are multiple resources. How many of you know Stack Overflow? I think that's the name, Stack Overflow, right? So Stack Overflow is an open forum where people post, doubts related to or issues related to coding and things like that. And I have seen that it has some good, answers from the public. So with that, I'm going to stop here. Let me go ahead and publish the poll so that you guys can give me your feedback. That's the end of our NumPy tutorial. You have learned how to create, access and modify arrays, perform mathematical operations and work with multidimensional data. I hope you are now more confident in using NumPy for your data analysis and coding projects. Also, if you additionally want to learn in depth about the Pandas library, which is based on the NumPy library, please check out my video on Pandas by clicking on the info card above. I've added the resources for this tutorial, including code files and datasets, in the description below. Be sure to check them out. If you found this video helpful, don't forget to like, comment and subscribe for more such tutorials. Have any questions or topics you'd like us to cover? Please drop them in the comments. Thank you for watching and happy coding.